want to put the...
Right. Maybe we should just go to... Or maybe we don't have internet access.
I don't want the free conference to show up for everybody either. Oh yeah, see?
Yeah.
Here's been spotty.
So we'll have to...
We can just put up in a Word and just have it on the screen maybe, but while we're doing the initial...
I don't know how to...
Can we kind of introduce while you try to figure that out maybe? Hello? Okay. All right. All right, everybody, we're about to get started.
Yeah, I don't know.
Well, maybe we're doing... Yeah, that's fine. Okay. All right. Good afternoon, everybody. My name is Niazi Dabani, and I am the co-chair for this year, along with Jared Bruce, who is just up here. So I just wanted to briefly welcome everybody to the conference and thank all the speakers and sponsors and everybody that's put in time and energy for this conference, and kind of go over some housekeeping while we're all here. The first thing is we have all the events will be in this azalea area in the foyer. The conference will take place in this room up until 5:30, and there will be a reception in the adjacent ballroom at 5:30 to 7:30. Everybody should have received 2 drink coupons with their badges. The first hour we have kind of beer and wine, and the second hour are for those drink coupons for 2 drinks from 6:30 to 7:30. The restrooms are past the second set of elevators for those of you who need to go to the restroom. And I wanted to also go over the poster sessions will be during the reception as well. Students can hang those up after 3:30, again in the adjacent ballroom. And there will be a break this afternoon at 3:40 for snacks as well in the foyer. So our sponsors are also in the foyer, so please visit them as you walk through the meeting space. And the final thing is the presentations. I know many of you have been asking about the presentations. We don't have the jump drives this year, but you have a nice little notebook and pen to take notes. We will be sending everyone that came to the pre-conference and conference, we will be sending links to those of you that came to those 2 sets, and we will have passwords to log in and get those slides for the presentations from the speakers as well as the poster handouts. Missing anything? The CEs, thank you. The big one, many of you are here for the CEs that we are offering for this incredible conference. All of those seeking, the psychologists seeking CE credits will be getting slips to enter and exit each conference. So today you'll have a slip that you need to write your name and sign. As you come into the conference, you should have handed them over to our wonderful student volunteers. Thomas is in the back. As you come in, and at the end of the day, you need to return your slip to get the credit for today. And the same thing tomorrow. When you enter the conference, turn in those slips, and as you exit, turn in those slips. If you are leaving the conference early, try to find someone to turn in those slips. Psychologists need to attend at least 75% to receive the full credit. There's no partial credit. And then for those athletic trainers and medical doctor and professionals, BOC and AMA is offering credits as well. You only need to place the slips as you enter the conference today, and then one tomorrow as you enter to receive your credit. And you will turn in your hours when you send those off. I think that is it. So again, thank you all for coming. I'm going to turn it over to Summer, who will be introducing our title sponsor for this year, Memorial Hermann. Thank you.
Welcome. I'm Summer Ott. I'm the Department of Orthopedic Surgery at UT here at the medical school in Houston and affiliated with Memorial Hermann, our title sponsor. I'm the director of the concussion program, and I'm very delighted that Mr. Rod Brace is going to come here and is here to welcome everyone to Houston. We're certainly proud of our city. We've had a little bit of flooding, but that didn't seem to deter anyone from getting here today, and I'm really pleased to have you. Thanks so much for being our title sponsor. Personally, I am just delighted for the team that I work with. We have a lot of good professionals. We talked about interdisciplinary approach to concussion management today, and I think we have a nice representation of that, and looking forward to the rest of the program. So, Mr. Rod Brace, if you would come and welcome everyone to Houston. Thank you.
Well, thank you very much. On behalf of Memorial Hermann and our Ironman Institutes, we welcome you to Houston. Up until a couple weeks ago, we were known as the Bayou City, or the Rocket City. We're now changing that to the land of 1,000 lakes, and hopefully the bayous have emptied, and the deluge that we'll get tomorrow will be quickly drained. But yes, indeed, we've had some water issues over the last couple weeks. Houston is also known for its Tex-Mex meals. And so we have strategically placed among you other Memorial Hermann and UT participants to give you direction. Just because it's Houston doesn't mean that all Tex-Mex is edible. And so you want to make sure that you get to the right places there. But we do, in fact, are very privileged to sponsor this particular event. As I was looking through the agenda and hearing about past conferences and the size of the audiences has grown over the years, it's very evident that your contribution to the science, your contribution to the well-being of athletes is making a continued impact in our great states here. And so we applaud you for that. We're very proud to be a part of that, and on behalf of not only Memorial Hermann, but the other generous sponsors who have joined us in welcoming you here, welcome to Houston. Thank you.
So someone who needs no introduction is Dr. Ruben Echemendia. He will deliver our presidential address. Certainly he has been instrumental in our organization. Can't thank you enough for all that you've done. I didn't expect to get emotional, but over the past few years, we certainly as an organization have grown tremendously, and it's so exciting to see all the partnership and the collaboration that happens. As Donna pointed out a few minutes ago, we have no office per se to run all these things that we do to put these conferences on, and many of you come back and return because you say it's so fun and there's so much networking, and we always have great food, so that's exciting as well. So again, no further ado, Dr. Ruben Echemendia for the presidential address. Thank you.
Thanks, Summer. I really appreciate that, and I want to add my welcome to everyone here. It's great to look out and see the room so full, and we really have a jam-packed program today and tomorrow that I think that you'll appreciate. My role today is to it's kind of the bully pulpit for the president. I get to say whatever I want, and we're going to, or I'm going to, really focus on a retrospective of this organization and to kind of comment on where we've been, how that relates to where the field has been, and how to get this back on track. And to do that, I'm going to be going back and forth in terms of some of the things I've learned, some of the things that I've observed, some of the things that we find in this field that is rapidly growing and is emerging. So the talk and my reflections are going to be primarily in the neuropsychological realm. So for my non-neuropsychological colleagues, I beg your indulgence in this. But at the same time, we're also going to touch on what I think are some of the interdisciplinary issues that we need to deal with in the field. So first, just disclosures. I do have consulting relationships with these organizations and receive financial support for my consulting services. I won't be talking about any of that today. So let's go back and take a look at what the zeitgeist was in 2010 when we were close to forming this organization. Basically, by that time, concussions had become a household term. It was hard to avoid newspapers that had headings or headlines about concussions, players retiring from concussions, concussions creating all of these issues. Second impact syndrome became a very palpable fear, a fear that persisted despite the fact that it's a very poorly understood situation, and in some situations became a rallying cry for doing assessments, doing evaluations, and establishing programs. And CTE was on the scene as well, the chronic traumatic encephalopathy. Again, it was very poorly understood. It continues to be very poorly understood. But it's popular, and it's prominent in the media and the public at large, in athletes, sports organizations, attorneys. CTE is talked about frequently and very often in an inaccurate way and with a lot of misinformation. New treatments have developed. There are diagnostic devices, various elixirs, sprays, and I'm serious about that. We were pitched a concussion spray that all you had to do was spray your face and your body for 7 to 10 days and your concussion would improve. What is the normal course of recovery in concussion? Oh, it just happens to be somewhere about 7 to 10 days. So you got your money's worth for buying what was laboratorily determined was Detroit water with salt added. Nonetheless, sports-related concussions became a respected area of study at about this time. Prior to that, it wasn't. You know, nobody was looking at it. If you talk to neurologists, they'd say, we never see concussions. We never see mild traumatic brain injuries. Our colleagues who do moderate to severe TBI, they're like, yeah, the mild stuff, it's there, but it's not that important. Well, guess what? It's become very important, and unfortunately, in some instances, it has become the injury du jour. There are many established medical disciplines and some, what I'm terming, newly formed, self-anointed, quasi-medical disciplines, who, and many of you can guess what that is, have become interested in concussion for the first time. And not to be cynical, but it just so happens that concussions now are a fairly large market to be able to build practices on, and many have done that. Sports organizations at all levels of play have adopted concussion evaluation and management programs and protocols. And we've had many consensus documents. We had the documents from the Concussion and Sports Group, the International Concussion and Sports Group, beginning with Vienna, Prague, Zurich 1, Zurich 2, and now we're going to have Berlin 1. Those documents were out there. Excellent document by NATA, the National Athletic Trainers Association, very, very well done document, and the Team Physician Society as well. Lots of consensus statements coming out, lots of issues coming out in terms of how do we evaluate and manage this injury. 2009, the Zachary Lystedt law was passed. That started a wave that now all 50 states have concussion legislation, and for the first time, legislation is determining how we evaluate and manage a medical condition. That really is fairly unusual. And as of 2 days ago, Senator Udall's bill has come out of committee, and that's moving to a national legislative level to actually help with consumer protection, which is sorely needed. So where does neuropsychology fit in all this? Well, there was a lot of early work by neuropsychologists in mild traumatic brain injury, and Gronwall and her colleagues in New Zealand really led the way along those lines. And then pioneers like my good friend Jeff Barth in the early 90s really brought the interest of the mild traumatic brain injury into the sports domain. The one who coined the term that sports as a laboratory being able to use sports. And at that time, his view was to really use sports as a laboratory by which we can learn about mild traumatic brain injury. Because here we had an unusual population that we could actually test them before they got hit in the head. And if we know what they looked like before they got hit in the head, we may learn something about the natural course of recovery of this injury over time. That model has just spawned a flurry of activity. The model continues to remain prominent to date, and the whole notion of baseline post-injury testing has really taken off. Just as an example, in 1995 at that time, Margot Patukian, who was a team physician at Penn State, and we developed a comprehensive collegiate program where it was a multi-sport program where in 95 we started doing baseline post-injury assessments, and that continues to this day. And really that was modeled on the work by Jeff Barth and some of the work that Mark Lovell was doing with the Pittsburgh Steelers. In 1997, the National Hockey League became the first professional league to actually mandate baseline post-injury testing and to have neuropsychologists assigned to every team. I'm a little biased, but I tend to think that the NHL continues to lead the way in developing and maintaining programs for the evaluation of professional athletes prior to and following concussion. U.S. Soccer Federation in 2000 adopted a baseline testing for its national teams in 2000. And like the NHL at the time, this really preceded the computerized testing. So the tests that were done at the time were paper and pencil testing, which was very labor intensive because you couldn't test any of the players in groups. You had to test them on a one-to-one basis. The NFL was also baselining and testing their players on a voluntary basis. And sports neuropsychologists really were at the forefront of what we were just talking about down here, a virtual explosion in research. An explosion into an injury that we didn't quite fully understand and continue to this day not to understand. And I think that we've gotten to a stage, and even back then, that we didn't even know what we didn't know. So it really is a significant issue with respect to the press that we were getting from the popular media, the press that was happening among parents and groups compared to what we really knew from a scientific standpoint. So as professionals, in many ways, we were flying by the seat of our pants, even though we were trying to gather new data and to try to better understand this injury. In 2006, the first textbook was produced with the title of Sports Neuropsychology, and some have argued that it actually named the field neuropsychology. The science and the practice of this area have really been advanced by a number of individuals. And I think it's important to name these individuals because they really have brought this field forward. People like Jeff Barth and Mark McRae and Grant Iverson, Mark Lovell and Mickey Collins, Bill Barr, who's sitting in the back there, Donna Broshek, Jerry Joya, Steve Machaki, Phil Schatz, Frank Webby, Michael Kirkwood, Rosemary Mosier, Beth Pyroth, Monroe Cullum, to name just a few. Just the number of people who have come together to really propel this process forward and this knowledge base forward. And then we have our honorary sports neuropsychologists. David Hovda, Kevin Guskowitz, the only true genius in this room, the only one to receive a genius grant. So when you see Kevin, make sure that you do the appropriate genuflection for him. Steve Broglio, Chris Giza, Margot Patukian, Stan Herring, also to name just a few. So despite all this stuff and all of this energy by neuropsychologists, we didn't have a home. We had no place to reside. So we had this thought. And it was, let's start a sports neuropsychology organization. Let's start this for neuropsychologists. And that just happened over a drink or two, or three or four, depending how bad the conversation got. And, you know, I talked to my wife about this, and her immediate reaction was, are you crazy? You guys are going to develop a professional organization from the ground up. Last night we had our business meeting, and Mark Todd, who was our treasurer, said that the way that I roped him into this was to say, all we have to do is open a bank account. How hard can it be to open a bank account? Well, that's a whole other story. So through discussions with Jeff and Jerry and Monroe and Chris and Jared and the like, everybody said, let's do it. So in 2001, 30 of us got together in an informal meeting in Chicago. We had no funding, no sources of funding, no support. Everybody got there on their own. And the goal was really to reach a consensus as to whether we should establish an organization. And if the answer was yes, what do we call it? You know, what are the various names that we could probably give or possibly give this organization? Obviously, we settled on the last one. What's the mission of this organization? What are we there to actually do? Who can be members? You know, the title is Sports Neuropsychology Society. So who can be members of that society? Who's a sports neuropsychologist? How do we fund it? And who constitutes the executive board? In 2012, we had a constitutional convention of our charter members. And these charter members were actually the ones who funded the initial organization. Everybody had to chip in $200. We all got together, threw in the money, we opened a bank account, and there we were, the Sports Neuropsychology Society. We drafted a mission statement and had it approved. Our bylaws were drafted and approved. The executive board was ratified. We had committees, and we actually came up with some future plans. And we decided to have annual meetings. The budget was, I think we had $10,000 in our budget at that point in time. No employees, just the volunteers. So in 2011, the Sports Nurse Society was incorporated, so I definitely lied to Mark when I told him it was just opening a bank account. Trying to get incorporated was a whole other story. And in 2012, we were given nonprofit status. And in 2013, we had our first conference in Minneapolis. And just to give you an idea of what that was like, I actually had to personally sign and say that I was responsible financially for the room block, speakers' fees, airlines, and everything else. So it was really a raw start. We did have really generous supporters and sponsors, but nonetheless, that's where we stood. Since that time, we've had some very successful conferences. And our conferences really represent our core belief. And that is that even though this is a neuropsychological organization, that the evaluation, management, and treatment of concussion is best done on a multidisciplinary basis. This is a complex injury, and an injury for which no one discipline has all the answers. Don't tell the chiropractors that. But nonetheless, there is no one discipline that has all of the answers. And we need to focus our attention at pulling together in order to best deal with this injury. Through this conference, we've been able to attract internationally known and respected faculty each year, and our attendance rising to capacity. If you look around the room, we are now at capacity for this conference, which is terrific. We have attendees from 33 states, 4 Canadian provinces, and a colleague from Finland. We now have a chapter in Canada, and we have a sister organization in Germany. This summer, we will have our first joint educational venture with the National Academy of Neuropsychology to put on a program on post-concussion syndrome in Vancouver. Over the years, we've had tremendous support from our sponsors. Last year, we began our first title sponsor approach, and Gwinnett Medical Center was our first title sponsor. You heard from Mr. Bryce earlier, Memorial Hermann being our title sponsor now. And we've also had unwavering support for every year that we've existed by the National Hockey League and the National Football League. and we are very much indebted to them for supporting our conference and supporting our mission. We've also had numerous sponsors throughout the year, many who are here today, and I would encourage you to visit them and talk with them. We have a great group of people, and I've been privileged to work with this great group of individuals, with Chris Vaughn, Mark Todd, Summer Ott, and Donna Broshek as the executive board, and then our incoming board with Chris Bailey, Mark Hersig, Frank Webby, and the president-elect, Jerry Joya. I also lied to all of them in terms of what they're headed for as they come into the new board. Key members of this organization have played incredible roles. I've done my best to list them here. I've certainly not been able to list them all. But it's important to note that this has been truly a group effort, and a group effort that I think has paid off in spades. So what I've learned is that Sports Neuropsych Society is really made up of a group of really extraordinarily talented individuals who are dedicated to their patients and really focused on advancing the research and the clinical practice. Unlike other professional groups that I've been involved with, there really is no infighting, and it's hard to get people to believe that, because most professional groups have a fairly high level of infighting. And you know, there's a remarkable lack of feuding, and egos are really checked at the door. You don't see people puffing up around here, and even leaders in the field, you can go up and say, let's have a drink, and you can do that and pick their brains for whatever it's worth. Don't go picking Jeff Barth's brain, though. Slim pickings. I've developed a deep respect for working with our colleagues in the sports medicine team and respecting and valuing what each discipline brings to the table and how we can each, through our discipline and our knowledge and background, bring something novel that, when tied together with everything else, is able to allow us to synergistically help these patients and to help them move forward. I can't speak enough about the value of athletic trainers to the sports medicine team. They are the front line of our sports medicine team, and I very much appreciate and value what you've done and what you do, we as an organization do, and continuously look forward to continuing to work with you on a collaborative basis. More than anything, I think I'm struck by the complexity of this injury. And every time that we learn something new, it's like peeling the onion. We keep finding about all these things that we really don't know. You know, how many years and how many millions of dollars have been spent on trying to find a biomarker of this injury? It's so elusive, there's a lot going on, and as Dave Hovda and Chris Giza have clearly made us understand, it's a moving target. It's a moving target that starts from the point of injury and then develops and changes over time. And that's not to even mention the developmental issues that are involved and the changing brain through development and how that changing brain gets affected through the course of injury. We don't know a lot. We really don't know a lot, and we need to continue pushing. And I think that it's important for us to focus on the athlete where we're going. You know, I think that there are many challenges that lay ahead. When I spoke to this group last year, I challenged this group to take a look at both the neuro and the psychology of neuropsychology. We have a tendency to focus on the neuro and not on the psychology. Perhaps because the psychology is a little messier, because there are lots of other issues involved, but the extent to which anxiety, depression, family dynamics are involved in this injury, not only at the very start, but in maintaining this injury, is crucial. The good thing is we have treatments for them. We have treatments for this that work. And if we identify it early, we can help prevent a catastrophic switch into really persistent post-concussion syndrome. So I really think that we need to move in that direction. The other thing that's amplifying all this anxiety is everything that you read in the media all the time. Every kid who has one concussion is now going to get CTE. That's what they fear. That's what's going on. We need to help them understand that that's really not the case. And we've put together a wonderful fact sheet that helps address that, and I hope you would take that fact sheet and see if you can use it in your practices and in your organizations. I think that we need to challenge each other to demand scientific accountability for new products, treatments, and instant cures. How many of you are lobbied on a regular basis about this new thing I have? Here is the new tool. This will diagnose concussion without any question within 3 minutes. This is happening constantly. People are buying into this. In some cases, it may be true, but in most cases, it's not. And we need to demand that they have validity and reliability data on this stuff before it goes to the market, not as an afterthought once it's been in the market for a year or 2 years. We really have to push this issue of validity and reliability. There are instruments out there right now that are being used for which there is not a single published paper on the validity and reliability of the instrument. Those instruments, in some instances, are being mandated statewide. That is a scary thought. It is a scary thought that there is an instrument out there that is being used for which there are no validity and reliability data that have been published, and yet is being used to make decisions on how to return youth athletes to play. That's scary, folks, and I think that we need to take on the professional responsibility of challenging that. Not to thwart development, not to say that we shouldn't be moving in those directions, just to simply say, you know what, why don't we do some tests and see if your product actually measures what you think it measures, and whether it does so reliably over time. We need to break out of our existing models of assessment and begin to use emerging technologies that allow us to do better jobs of assessment, that allow us to assess across different age groups, that allow us to assess across different linguistic groups. We're not doing a real good job on that because we tend to be fixated on older models. And I think we need to be willing to break those models and take a look outside of that box. The issue of development is huge. Jerry has really led the field in terms of moving towards developmentally appropriate and age-appropriate tests, and we really need to move further in that direction because it's sorely needed, since most of the folks who are having the concussions are youth athletes. They're not our professional athletes, they're our youth athletes. So borrowing from Mike McCrae, we need to push forth towards an integrated biopsychosocial model of evaluation, intervention, and management. So in closing, as I look around the room today, I'm struck by the diversity of disciplines, diversities of thoughts and ideas that are represented in this room. We have physicians and nurses and athletic trainers, physical therapists, optometrists, neuropsychologists, attorneys, and students, all coming together to learn more about this injury and to be willing to work with each other in terms of moving forward. And I'm truly convinced that by working together as a multidisciplinary team, we can further develop the tools that we need to help those individuals who entrust their care to you or to us. And for that, I thank you. I thank you for your attention. Have a great conference. It's meant to be a good time, and use your drink tickets wisely. Thank you.
Hi, I'm Donna Broshek. Thank you all for being here, and it is my great honor to thank Ruben on behalf of the Sports Neuropsychology Executive Board and committees and members for his incredible service as founder and first president of this organization. And I'm sure many of you know about his incredible scientific accomplishments, all that he does professionally in terms of working with athletes. But what you may not know is how incredibly into the details Ruben is. He is on email. He's taking care of so many details personally, and he has devoted hours and hours and hours of his time to getting this organization off the ground. And so he is just an incredible leader and colleague and good friend, and it's my great pleasure to present him this plaque recognizing his service from 2011 to 2016 as founder and president of this organization.
Thank you. Thank you all.
You didn't know we were going to dance, too.
You know my password, right? Yeah. You need your glasses. Madeline 2015. Okay. Please, one time. Come on, one time. This is your. There you go. Great.
Well, good afternoon, everybody. I'm Jerry Joya. I'm the one that Ruben lied to as well. So thank you for your lies, Ruben. But the one thing, Ruben, you should recognize is my wife will come after you if you really lied badly. So it's my distinct pleasure to introduce our next speaker here. And let me just say that the nice things I say about Dr. Jim Hujak is not because he bribed me with his drink tickets. So he's got to leave, and he said, you can have my drink tickets. And so now I really have to say nice things about Jim. Jim is, I think Jim and I met 5, 6, 7 years ago as we were undertaking our own work in pediatric concussion. And I soon learned that I wish that we had many more neuropsychiatrists, pediatric neuropsychiatrists like Jim working with us, and it's certainly something to aspire to, and he is a great model. He is the Thomas Achenbach Professor of Child Psychiatry at the University of Vermont, and is in the College of Medicine there. Jim, I'm assuming you founded probably the Vermont Center for Children, Youth, and Families. Jim is unique in so many ways, as you're going to learn from his lecture here, in that he really sees this whole issue from a brain health perspective. And the way that he has modeled his research is to not only look at the micro levels of the genetic contributions, but has really looked at the macro levels and how you really build a milieu to further brain health. If you would like just a little chuckle, you should Google James Hujak NBC and click on the first link, and you will see a picture of Jim there in his fine, I'm going to do it left-handed, Jim, but in his fine, holding a brain in his hand, ready to throw it into his class. He has a unique way of engaging his students. He has a unique way of really bringing to the university an engagement of his students And it is a pleasure today to hear Jim talk about genetics, epigenetics, and neuroplasticity of sports concussion in young hockey players. Jim Hudjak.
I really appreciate the opportunity to stand in front of you today. This work and your discipline are both passions of mine. Trained at Washington University in St. Louis, where we were trained as brain-based physicians, where we understood that all thoughts, actions, and behavior emerge from the brain, and that to promote brain health is the real duty of those of us who care for young people. These are an example of the kind of work that's funded at my lab right now, funded by NIDDK to look at the genetics of exercise behavior and its effects on the human brain, the neurobiology and genomic plasticity of child abuse, more on that later. We've been following 10,000 children since 12 weeks in utero in Rotterdam, and we're doing this year brain, heart, lung, and gut imaging under the direction of Frank Verhulst. We've followed 5,000 twin pairs from birth into now their 12th year of life. Did whole genome sequencing, whole genome copy number variation and association in this group. We have our array of sports concussion studies, and we've now just been named one of the sites for ABCD, the National Institute of Drug Abuse's $300 million project to follow 10,000 10-year-olds for 10 years with neurocog genetics and neuroimaging to watch the pathways that children follow. At our place, Hugh Garavan is the PI in that. My Conco team are here: Matt, Jay, Scott, Catherine, Richard, Catherine, a neuropsychologist, Matt, a psychologist, physicist, you all know. So I've been asked by Jerry and Ruben to follow this outline, and I gladly do it. And I'll try to do a good job understanding that most of you maybe aren't geneticists, and for those of you who are, I apologize if I oversimplify things. But a lot of us have been taught over the years that our genetics make us who we are, and although that's true to a certain degree, it's far from a total truth. I'll discuss our genetic makeup, I'll discuss epigenetics, and then I'll discuss it in the context of neuroplasticity, that the effects of the environment on the epigenome and on the brain predicts who we are and who we will become. The basic premise of my work is, as the chair of health promotion and prevention for the field of child psychiatry in this country, I'm responsible for figuring out ways to get kids from tough spots to happier spots. And when I started to realize that the rates of pediatric concussion, particularly sports-related concussion, was higher than things that you read about all the time: attention deficit hyperactivity disorder, autism, childhood anxiety disorders, I decided that pediatric concussion should be treated as an epidemic and draw the full attention not only of pediatrics but of child psychiatry as something that deserved the kind of attention and attitudes that, say, autism does. And Ruben spoke beautifully and elegantly about how far and how quickly your field has grown, but the disorder autism has received literally 1,000 times more money than the study of pediatric concussion, and pediatric concussion is 130 times more common. Concussions associated, as again Ruben talked to you beautifully about, increased rates of attention problems, ADHD comes to mind, anxiety, aggression, and emotional regulatory problems that in themselves lead to overprescription of agents that have little effects in those domains in children because they've been discovered and tested in adults. My main hypothesis is that the developing brain is at greater risk for the negative outcomes of sports-related concussion than more mature brains, and I'm going to try to bring that forward. Beautiful work from Paul Thompson. What you're looking at here is the cortical organization, the final mapping of the human brain. I'm going to show you from age 8 to age 22. I'm going to point out some things important. Oops. 8, 10, 12, 14, 16, 18, 20, 22. If you look at it one more time, 8, 10, 12, 14, 16, 18, 20, 22. Those regions of the brain that came in last, all of you noticed, the VLPFC, the OFC, the PC, these areas of the brain that determine who you are when you're grown up. your executive processing skills, your emotional regulatory skills, your ability to feel reward, your ability to control your emotional reactivity, rage, and aggression. And if you start to think of this in context of this beautiful symphony from age 4 to 22, the symphony of the developing brain, where the parietal, frontal, temporal lobes, cerebellum are all undergoing cortical organization, synaptogenesis, myelination, apoptosis or programmed cell death or pruning. Yet the business end of it doesn't occur late until the second decade of life. And these incredibly vulnerable brains and the environments that they come up in are what predicts what kind of people we will become. Certainly this is under genetic control, but the environment that the child endures or is rewarded with will have a greater impact on the outcome of that brain than the genes he or she started with. This summarizes all of my work across all of those studies. What we do, what we engage in, changes gene expression through epigenetic modification, changes the structure and function of the human brain, and ultimately your thoughts, behaviors, and feelings. Incredibly competitive disadvantage if you're not training people from the brain up in order to maximize the idea of building a healthy brain brings a healthy body after. Put it real simple, I call it the dumbbell effect. If I take a 5-pound dumbbell, then 10, then 20, then 30, you'll all with full confidence say, well, your biceps will grow. All I changed was the environment. I changed the amount of weight I put in my hand. The same is true with the human brain. If you put positive, brain healthy prompts in that palm, that brain develops in the way you hope it would. But put negative things in its way, negative things will follow. So, in the Netherlands with Dorette Boomsma, the Netherlands Twin Registry, a recent winner of the Spinoza Award, often referred to as the Dutch Nobel Prize, we've been following 70,000 twin pairs since, 70,000 twins, 35,000 pairs since birth. And it's a pretty simple kind of science. We compare and contrast identical twins who have a single egg, a single implantation site in the uterus, and have 100% identical DNA. We compare them to fraternal or dizygotic twins who come from 2 different eggs, 2 different implantation sites, and only have 50% shared DNA. The degree to which twin 1 and twin 2 share a trait, if you're identical versus non-identical, allows us to understand the degree to which genes matter or environment matters. The child behavior checklist, something that Jerry and I work in concert with his brief, measures the ability of children across 87 cultures, 118 dialects around the world, but it just compares you on your aggression, your attention, your thought problems, and your withdrawn behavior. Now, I ask you to look at this because most of you are pretty familiar with the impact total symptom score, and I'm going to show you in a little bit how they map almost perfectly on this internationally accepted way to understand emotional behavioral health. So what I did is I took those twins and I looked at the 3 most common traits that all of you have. And this is important. It's not you have ADD or not. It's the degree to which we're inattentive, the degree to which you're anxious, the degree to which you're naughty. And you'll see a central theme that runs through my work. Whatever you were before your head got bonked, you're going to be a little bit more of that after your head got bonked. What you bring to the dance matters. So we'll start with little Jerry Gioia. Now, you know these nasty little boys, they get in fights, they're rough and tumble. Well, I looked at 30,000 twins with Dorette and the team, and what we found read, genes matter, 60, 70%, whether you're a boy or girl, whether you're 3 or 25. Your genes account for 60% of the variance on why you might be aggressive, but your environment counts for the other. And everybody in this room would like their kid to have these aggressive genes because that's how they want to be the best at this or the best at that, the best at this. But your environment tells you where to stop. And you put a storm around these aggression genes and you're going to get all the problems that we deal with. And we start with the female variant of me. Looked at the largest twin study of people with attention problems, and again, we showed the same thing. Everybody's tied up on these 70% of the influence being genetics, red, but in fact, it's that 30% of the influence that's the environment and you're going to see in this own work as it pertains to hockey concussion in kids, that will dictate how your attention problems are felt. And then all of us, largest study ever done on anxiety. This was 30,000 pairs, and you'll see, and most problematically and most interesting with respect to the kinds of things we'll talk about today, the contribution of genetics goes down as you get older, and the contribution of what's happened to you in life goes up as you get older. The environment matters more when you're a young adult and an adult. We've researched the crap out of every childhood behavior we could come up with, and we can tell you we published almost impossibly to read papers on all these traits. I've also published a book that's equally impossible to read on these traits. You can get it on Amazon.com. Everything's influenced by genes. Obviously, everything's influenced by the environment. Obviously, it's not genes versus environment, it's genes and environment and how they interact. That matters. So we still said we're going to go find genes. And so we did genome-wide association studies. We did copy number variation studies, sequencing studies. I'll tell you about that exciting work in a second. But first, I wanted to keep you in twin studies, because you saw the twins of anxiety, depression, aggression, 60, 70%, 60, 70%. So how heritable is concussion? This is Dorette right here, and one of my postdocs, Eileen Crean. Well, first I'll start with your total symptom scores from your impacts, and you'll see they map on our CBCL. And that's not surprising, because if you bruise a knee, you're going to have knee symptoms, and if you bruise a brain, you're going to have brain symptoms. And those brain symptoms are anxiety, sadness, inattention, aggression, and emotional regulatory problems. So we looked at these twins and found 13.3% of them had had a concussion. The Dutch play a lot of football. They love to tell you that too. So we did those same twin studies, but here the red bar would only be accounting for 17%, not 60, not 70, not 75%. And here we can thank God. She would have been an evil deity if she said, I got an idea, let's make concussions genetic. Have a whole bunch of people just running around banging their heads into walls and getting concussions. But here's the story. Of those 13.3% of those Dutch twins, when concussed, massive increases in the headache symptoms to P70s, to attention problems, to aggressive behavior, to other odd behaviors such as obsessional preoccupation, to externalizing and internalizing behaviors. These conditions that everybody says is genetic. So we have a non-genetic concussion cause of a genetic condition. And you can see why we have so much struggle finding these genes, because in this scenario, these are not genetic causes of. They're vulnerabilities resulting from. Summary of twin studies. Concussions are not likely independently influenced by genetics to the same degree of other human behaviors. That's a good thing. You all understand that? There'd be no adaptive advantage to constantly going around and getting concussions. However, other behaviors, aggression, inattention, impulsivity, may indirectly increase the risk of concussion. Kids who aren't paying attention, who are impulsive, they are maybe more likely to run into walls. Any of you who've coached hockey, as I have for over 30 years, can tell you that our sport seems like a magnet for little kids with ADD. How many times I've been hit by pucks by kids who are supposed to be whistled in? Unbelievable. And then once concussed, here's this circularity, this hakuna matata of this whole deal. Once concussed, these things even become more severe. This is that point that I think many of us agree with, and Ruben talked about it with me earlier. It's what you have, you get banged, it'll get a little bit worse. All right, molecular genetics. You are all raised in the oh God genetic area, one gene, one disorder, Huntington's disease, Tay-Sachs disease, Duchenne's muscular dystrophy. You get the gene, you get the disease. We're now in a oligo and polygenetic world where you might need 5, 10, 15, 20, 30, 1,000 SNPs contributing to your risk, creating a statistically very difficult scenario to find genetic tests that would say you're at risk or not at risk. Let's use ADD. Let's say you have to have these 5 SNPs, these 5 genes to have ADD. Here's mom. She's a bit of a daydreamer and artistic, but otherwise very successful. Here's daddy's aggressive, relentless. works very hard, very successful. They see each other, they like each other, they cross. Here's little kid number 1, here's little kid number 2, here's little Bobby, inattentive, hyperactive, impulsive, and aggressive. There, but for the grace of God, go everybody in this room. Everybody in this room has had a family member touched by one of the psychopathologies. It's not because they're bad people. It's by the grace of God, the genes they got, and the environment that they came up with that either protected them from or put them at risk for these outcomes. So, you got a gene, we'll test you. Except, and you've all read ApoE, the very famous Alzheimer's gene is probably a concussion gene. Or tau, we have Dr. Brody here, one of the world's experts in tau research. That's a concussion gene. Certainly the main protein of interest in CTE. BDNF, brain-derived neurotrophic factor, is a concussion gene. Well, there's very little support that that's actually true, although you can get tested for these things right now. And I'd like to point out, in the same way Ruben spoke with great courage about other tomfoolery, getting and paying for these tests and concussion, is as effective as those other tests that Ruben was talking about. Genome-wide association studies now done on hundreds of thousands of kids, 0 findings in concussion. Sequencing to date, 0 findings in concussion. Whole genome sequencing, 0 findings in concussion. But you can still get those testing done. You can go to 23andMe. You can go to Human Longevity Incorporated, pay $10,000 to get your whole genome done. But none of these companies even claim to be able to find concussion. They will find your lost aunt in Bulgaria, but they won't find your concussion. Even when we all got together at one of these summits and wrote a big paper about how to move forward using genetics to say quit hitting people, I present the references at that time that came forward. I wrote this text, ApoE, BDNF, and tau. I went to the internet today, and I went through all the papers published in the last 4 years, only found 2, one that says the serotonin genes have no role in predicting concussion, and ApoE may, in certain circumstances, be associated with concussion risk. If you put in any other disorder and put in the search terms I did, you would have had thousands of papers. So doing molecular genetic testing? No. But how about epigenetics? Now, epigenetics is post-genetic modification. You remember we got A, C, G, and T, and we got 2.7 billion of these base pairs. That gave us our genome. You might have the most beautiful genes in the world, but if they're turned off, you're not going to benefit from them. So in this field, brain injury among immature rats results in decreased histone acetylation and methylation in the hippocampus, memory, mood, affect regulation. Global cellular hypomethylation has been reported with TBI, particularly in the microglia and macrophages, areas that Dr. Brody works in. These and other mouse models started to say it might make sense to look at what happens to your genome after you get bonked as a way to understand this. This sounds a little more difficult to understand. It isn't. A, C, G, and T connected by a phosphate backbone. C always goes with G, phosphate, CPG. A always goes with T, APT. And it winds in this beautiful helix. If you put a carbon with 3 hydrogens, a methyl group, right on one of those P's between a C and a G, you have a CPG methylation mark. It's this. It's like putting a tree trunk on the train tracks. Your train tracks still look like train tracks, they just can't run. Your genes are silent. Here's an easier way. Identical twins separated at birth. They have 100% identical DNA. Their A, C, Gs, and Ts look the same. Their genetics tells you why, even to the way their pinky finger curls off the bottom of the beer can, they have some similar phenotypic and similar behavioral traits. They each married a woman with the same first name after a reunion 35 years later, and they have the same breed of dog. There is something to genetics, but their epigenetics tells you that one of these men was... All right, it's clear. Now, the same could be true in the genes that require your brain to be healthy. the stress receptor system, my friend Michael Meany noticed in nature there are two kinds of mouse. A mouse mom who's called a high archback nursing licking mom, and she took care of her pups. She licked and groomed and licked and groomed and licked and groomed her babies. But there was another mom, not a genetic variant, but just not that into it. She would lay there flat, and her pups would come in, and she wouldn't do anything special. She wouldn't lick and groom. They spent the same amount of time with their pups. Mike noticed the high licking grooming puppies weren't stressed out, were pretty smart, would kill it in maze tests. The low licking grooming pups, stressed out, struggled in maze tests. Here's a high licking grooming mom doing her thing. Licks and grooms and licks and grooms and licks and grooms and licks and grooms. Beautiful story. When this paper came out, I sent my mom roses and thanked her for licking and grooming me. I'm going to show you the two kinds of offspring. I'm going to show you first the offspring of a high licking grooming mom, and second the offspring of a mom who doesn't lick or groom. It's called the platform test. I'm going to check my quadrants. I've never been here before. It's a bit scary. All right. There's nothing really interesting here. I'm going to go off to college. Low licking grooming pup. Again, instincts try to drive, but you can see they're chaotic and they're reversed. Turns to the human handler, says, help me, take me out of here. Goes on and on and on. You can look at the hippocampus and you can look at the gene expression of the stress reactivity gene in the low licking groomers and the high licking groomers. And you can see with your own eyes that the kids who were groomed, cared for, had more of these stress reactivity proteins. Their biceps were bigger. Mom licked them, biceps got bigger. Y'all get this? Mike didn't win the Krauss Award. Brody, he got 1.5 million euros for this. This is a check. I want it. He didn't win the award for this. He won the award for cross-fostering. He took, at birth, the pups of the low-licking grooming moms, gave them to high-licking groomers. The pups of the low, high-licking grooming moms gave them to the low-licking grooming moms. Completely reversed the behavior, completely reversed the genetics, the epigenetics, and completely reversed the structure and function of the brain. So it had nothing to do with genetics. It had everything to do with environmental mediation of the genes of those mouse pups. Do you all get that? So what if it's abuse and neglect? Well, Mike showed that people who suicided after years of neglect, all of these little tiny marks here are called epigenetic marks on that same gene of those mouse moms who are licking their pups. For Ruben, you might want to note, Ruben, this is the Dalai Lama. Mikey gave him a Team Canada hockey jersey, and the Dalai said, I love the game. I repeated this in abused teenage children. I compared and contrasted young women who were abused in teenage versus non-abused and showed the same genes were shut down. I then looked in 100 children who were abused and 100 children who weren't abused with my colleague Joan Kaufman, and we found not only did epigenetics affect obesity genes, diabetes genes, hypertension genes, but most stunningly affected these three genes that are responsible for repairing your brain once it's had a shearing injury. Particularly the TPPP gene, tubulin polymerization promoting protein. The more abused you were, the more hits you took, the smaller your brain was. Here's cortical white matter volume, which the brain is built on, and the number of methylation marks. Well, this really made me say I should look at hockey players. And I should look at what else happens when you get abused. And first, these are child abuse kids, and again, I showed the more trauma that the child endured, the smaller the total cortical volume, which makes sense. If your white matter is smaller, your cortical volume might be smaller as well. I showed the greater your abuse scores in girls, smaller your right frontal middle gyrus and insula. I'm going to show you these in hockey players in a second, so they'll all come home. And the smaller the hippocampus. Now, these are the same regions of the brain that you're going to hear about repetitively going forward in emotional regulation, in aggression, in substance use and abuse, etc. And sadly, in little boys, what we found was the anterior cingulate and the OFC, the regions of a brain with aggression. The more hits they took, the more aggressive they were. The more hits the girls took, the more emotionally dysregulated they were. So then we moved to our guys. So we took these 35 hockey players and we said, we're going to genotype you, we're going to neuroimage you, we're going to do molecular genetics, we're going to do epigenetics, and we're going to do pre and post concussion protocols. We baselined, not just with neuropsychology, which I applaud, and you guys led the league. We baselined their brains and we baselined their genomes. And we found out they drink. Now that's a shocker. I'm sure none of you ever knew that a hockey player would take alcohol in. But what we found is a correlation between alcohol consumption and epigenetic modification of key genes associated for cortical thickness in this region of the brain. We also found that the more concussions they had, the more attention problems they had. And we found specific methylation markers associated with this region of the brain with this kind of behavior. These were the same regions you just saw in little boys and little girls who were victims of child abuse and trauma. These kids had 0 scores of child abuse and trauma. They were voluntary participants in the greatest game. We saw, using susceptibility-weighted imaging, an imaging technique I'll tell you about in a second, that there was an increased rate of basal ganglia-free red blood cell degradation product, meaning a red blood cell slips out, it degrades, and hemosiderin is left in. The more hits you've had, the more likely you are to have that residing in that area of the brain. Here you can see it lit up like a little Christmas tree, little sparkles, just almost think of that as Farron. We did whole genome epigenetic analysis, and the top hit for hockey players was the transferrin gene, the gene that's responsible for controlling the removal of these degradation products. And again, this signal correlated to this basal ganglia region. So, summary. Our preliminary data is preliminary because, as David doubtless will tell you, we need to get these samples a lot bigger. But we are increasing the size of our sample to run more powered analyses. Yields the possibility that concussive events, not unlike our published studies in child abuse, are associated with epigenetic changes that may impact the structure and function of the brain. Now, what about their brains? Here's the kids again. We imaged them. We said we didn't know what concussion was, as Ruben said, so we just called it a quantitative brain insult. But we did cortical thickness imaging by doing a map RAGE, where we just found the ribbon or the cortical thickness of the outside of these kids' brains. We then turned gray-white and white-gray using a 3D2 flare where we could look and see if there were any insults in the white matter that you heard earlier in child abuse was smaller as a result of abuse. We used susceptibility weighting imaging so we could look and find microhemorrhages, even a single blood cell and its degradation products in the brain. We did diffusion kurtotic imaging so we could look at the direction and flow of fibers in the brain. We can then map things like the motor pathways and watch how these pathways ascend up, and then we can match those pathways to their terminus, the cortices that the motor pathways are supposed to serve, here the motor strip. Now keep in mind, my idea and my science was, what if there's an insult in one of these pathways, white matter, will it affect the structure and function of the cortices, your thoughts, actions, and behavior? We also did a cheap man's PET scan called pseudo-continuous arterial spin labeling, which just shows us blood flow, and we have a marker called T1-Rho, which we hope can help us find tau. So you've got these beautiful athletes. We enrolled 30. They signed up. They did all the baseline stuff. And then one of the geniuses went out and got braces when it was time for imaging. He's like, hey, doc, look, I got braces. Isn't this great? I'm going, yeah, it's really great. Let's put you in the scanner, see how you like it. All images were read by safety by a board-certified neuroradiologist blind to the study. And I was stunned to have to call 17 of these 29 boys' parents. That I did not see coming, because these were healthy kids, half of whom had had concussion remotely, the most recent concussion 3 months ago. All were cleared to resume their prep school play. All had already had college deals, and we chose them because we knew they were likely to continue to play hockey. We also found a brain tumor, 2 hemorrhages in the caudate nuclei, and a case of suspected multiple sclerosis. So this little boy had a frontal lobe tumor that was malignant. We were able to get it out, save his life. First he was mad at me, then he was happy with me. He's still playing hockey right now in Canada. When I called his neurosurgeon at McGill, I said, how can he be playing hockey? And the neurosurgeon said, he's from Canada. I sent this image around the United States, including WashU and other centers blind. I said, can you guys read this for me? 10 of the top centers in the country read this as multiple sclerosis. You can see the pathognomonic fingers of Langer's drooping out of the bottom of the ventricles. This kid's still playing college hockey right now. He's symptom-free. If we had not baselined him, we would say concussion possibly had caused this. I don't think so. This is transient hyperintensity in the splenium. The splenium is the end of the corpus callosum that connects your two hemispheres. It's the teardrop at the end. He had a pure image at the beginning of the study. This was his post-study image. I was scared to death. I loved the kid. I called his junior coach. I said, did he have any concussions? No. Do you have any hits? No. We reviewed all the tapes. He's 6'5", 265. No one touches him, and he doesn't touch anyone else. I guarantee you, Doc, he didn't get hit. So I brought him in. I said, X, what the heck have you been doing? What were you doing right before the image? He was blackout drunk in St. John's. The team went down for a post-season recovery. I treated him by making him go off with his mom to Canyon Ranch for a week and rescan him, and it was all better. His mom doesn't drink. Here's those hemorrhages in the caudate nucleus. This is the home of dopamine, attention, concentration, and mood. We showed the number of reported concussions correlate with left insular cortical volume, which is aggression and emotional dysregulation. We showed the more weed they smoked, the smaller their right frontal middle gyrus is. And by the way, if you don't need to know the right frontal middle gyrus, it's the area of the brain that goes like this. Dude. So with Matt Albaugh, we looked at this cortical ribbon. It's a pretty simple science. We just looked at the thickness of the gray matter, and we correlated it to the number of concussions the kids had. We could do this because we've already published multiple papers in where attention lives, where aggression lives, where anxiety lives in the human brain, and these are all of our papers published on that. We said, since we know where these houses are, why don't we look at them in kids who got concussed? We used the impact test and the PCSS, which I showed you earlier, maps on the same scales that we use to publish all of our prior neuroimaging studies on typically developing children. Cortical thickness, does it change when you're concussed? In our first paper on this, we showed a correlation between an age by concussion history, which pointed right to our central thesis. The earlier on you were getting the concussions, the smaller, and this is very important when you're looking at the bilateral temporal parietal and frontal cortical regions, so executive processing and emotional control. Here's your attention problem symptoms, attention and concentration, emotional regulation. Total symptom score correlates with something, and cognitive symptom scores correlates with something that those in the neuropsychology literature know as the default mode network. And the more concussions these boys had, the more evidence was they had a lack of regulatory control in the default mode network. Steve Peterson and Brad Slager at WashU are now doing advanced analysis of this data. So our conclusions on cortical thickness was that in the frontal, parietal, and temporal regions, the more concussions you had, the smaller those regions were. Those are hard regions to have go sideways on you if you're in school, trying to pay attention, trying to concentrate, and trying to get on with your life. These regions play a role in the emotional regulation, attentional processes, and aggression. Then we looked in the white matter area. My son was one of those players, and I also took the test myself just to baseline it. And when the kids were done, I said to one of my postdocs, at least I don't have any of these white matter injuries in my brain. You're actually streaming this to people? So I probably couldn't say what I really call this guy. This is me. We have an affectionate name for him in our lab, but we won't use it publicly. I said, Matt, I don't have any of those things. And he said, yeah, you do. I said, this is awkward. I have 18 of these. Now, neuroradiologists used to call these things UBOs, unidentified bright objects. And they say that it's okay to have one or two of these per decade of life. I'm either looking real good as a 180-year-old man, or I've got some problems, maybe. So we started publishing on this. White matter hyperintensities is when in that white matter, remember in our trauma kids, we showed the more abuse they had, the smaller their white matter was. The more white matter hyperintensities you had in the published literature, the more affective regulatory problems and other psychiatric problems you're known to have. This child is playing elite college hockey. He has 18 of these white matter hyperintensities distributed throughout his brain. We took all the players and we mapped their white matter hyperintensities, and we showed that the majority of them lived in the superior longitudinal fasciculus on the left and right side. Now, why is this important? This is a fiber tract pathway that connects the posterior and anterior regions of the brain. It carries most of this information forward and back. And when we map them out in the kids, at first it looks like a gamish of little damages in the brain. But now you can see they exist on the superior longitudinal fasciculus and their terminus, the forceps minor and the uncinate, which play a massively important role in serving the cortical regions of emotional regulation. And you can see bilaterally, these things are almost mirror images of each other. So you remember the beautiful work by Joel Stitzel. When we start to think about this, look at that shearing injury, and look even where the damage is being demonstrated without any knowledge of this work. The setup is perfect for the superior longitudinal fasciculus. The SLF, forceps minor, and uncinate are implicated in voluntary, and most important for you to understand, automatic aspects of emotional regulation. That boom, that explosion. We showed the more hyperintensity you had, the more flare regions, the more affective dysregulation problems you've had. So in summary, it looks like it's not just the cortex that gets in trouble, it's also the white matter. And the white matter serves the cortex. We want to move this forward. We're just in the beginning of some of these studies. We're doing soccer now because we were able to get soccer funding. But we wanted to do females. And let me just make this point. Here's our female athletes. For anyone who's ever tried to do neuroimaging of 30 high school male athletes, you deserve a present. They're barely human. They're hard to get to do anything, but they disobey with great enthusiasm and affection. Women are like a completely different species. They're so on point. Yes, doc, what about this? Is this why I'm so angry all the time? And you just don't know how to talk to them. And interestingly enough, look at this first little girl that comes off this scan. These hyperintensities are distributed throughout her entire brain. And some of the beautiful work by people in your field that you don't have to get hit to have shearing injuries on the superior longitudinal fasciculus, as you guys know. Understanding the pathophysiology of concussion at a genetic, epigenetic, structural, and functional way will continue to be the focus of my lab. We need to understand the contribution of individual variation to the differences in risk for and outcome from. We intend to study the very young, 8, 10, 12, 14, and 16-year-old athletes in order to understand developmental pathways. Because I believe it's time for us to protect our young people before they reach age 16, 18, and 20, where they could realize the true potential of their brain. In summary, our preliminary research and our published data in child trauma, not hockey yet, support the data that the developing brain may be more vulnerable to the negative sequelae of concussive events. Thank you. Jerry says there's time for questions. Yes? Oh, I think probably all the training that I ever did, I wanted to be able to do research on poop. That was like a big part of it. I want to be able to say it in a scientific way. The gut-brain axis now is absolutely blowing up. And the work that's come out of Cork in Ireland, John Gay and others, shows beautifully that the occupants of your bowel predicts your attention, your concentration, your anxiety, and your sadness. So we do full biomics, metabolomics, and genomics, and are thinking with greater enthusiasm that the biomics may be more predictive. And what's wonderful about that, probiotics, Greek yogurt to start your morning, change the bowel content right away. It's pretty easy to do. This is an old literature, and we're just looking for ways to help kids forward. And in our own concussion treatment guidelines, we don't go in for fadism. We go in for established things that work in the corollary symptoms of, and biomics and nutrition is a huge one. Everybody knows when their baby had an upset tummy, they were hard to be around. It's no different if that baby's suddenly 6'2" and 225 pounds. Any other question? All right, well, thank you guys for having me down here.
So, I don't know. These are PowerPoint slides, so whatever you got. PC
Is this your computer here? Yeah, why don't you come up and help? Co-chair of the program here at the 4th Annual SNS, and I could say that I was very excited when our next speaker agreed to present here at this conference. Dr. David Brody is a professor of neurology and an associate professor of biomedical engineering at the Washington University School of Medicine. He received his MD and PhD from Johns Hopkins University. He's on the editorial boards of the Journal of Neurotrauma and Acta Neuropathologica. He's received millions of dollars in research funding examining the neuropathology of concussion from the National Institutes of Health and the Department of Defense. He has more than 50 publications in journals including Neurology, JAMA Neurology, Brain, and Neuroimage. We're really honored to have Dr. Brody presenting at this conference. Please join me in welcoming him.
Hi, thanks so much. It's the first time I'm meeting a lot of you guys, and it's really an honor to be invited to this group, so thanks for the invitation, Ruben. I really enjoyed Jim's talk, and I'm going to talk about something completely different that's really not related to science at all. So this is going to be, what I'm going to talk about instead is my clinical practice, which is I run the concussion clinic at Washington University, and as Ruben said, this is clearly a multidisciplinary clinic, and we work with a lot of neuropsychologists and therapists and trainers and a huge variety of medical practitioners of all types. But what I wanted to tell you about, what I was invited to talk to you guys today about, is the pharmacological management of various neurological sequelae of concussive traumatic brain injury. And so I'm going to tell you that, let's see, okay, how do I do the next slide here? No? Usually it's just, oh yeah, okay, there we go. Got it. These are my mandatory disclosures as some research support, some consulting. None of these constitute conflict of interest, but the only thing that I will say just up front is that a lot of what I'm going to say today can be found in this book that we put together a couple of years ago called the Concussion Care Manual that's published by Oxford University Press. And so some more details, what I'm going to tell you about is just sort of the tip of the iceberg of all the things we do in the concussion clinic, and you can hopefully read about the rest of them. Okay, so the bottom line first. Most patients with concussions don't need any pharmacological therapy at all. But pharmacological treatments can be an adjunct to rehabilitation and lifestyle management interventions for the more complex concussion patients that have unusual or difficult sequelae from traumatic brain injury. There's no pharmacological cures. We can't cure concussion or any of these diseases with any of these concerns with pharmacology, but we can sure help some of the time. So sometimes they can be helpful. But some pharmacological interventions can be harmful, can do more harm than good. So sometimes knowing when to withdraw or take away some of the pharmacological interventions is a very helpful thing. And most importantly, this is not science. Most of what I'm going to tell you today is based on so-called expert opinion, which just means us making the same mistakes over and over again for more and more years. But no, it's based on our experience and what we think has been working over a period of time. And the evidence is scanty, and there's a real great need for randomized controlled trials in this domain of treatment for specific problems following concussive traumatic brain injury. So, and then the last thing I wanted to say is that I'd like this talk today to be interactive. So rather than asking me questions at the end, why don't you guys please stop me and ask me questions as we go through each slide, each domain. I think that'll be more interesting, more productive for you. What I'd really like to do is be able to answer your questions about that you may have and engage in a little bit of dialogue. So if that's okay with you, please, I'm going to stop and look for questions after each slide rather than at the very end. Okay? I actually don't have that many slides. Okay, so just going to get right into it. Probably the most common, delayed, and persistent complaint that I see in my concussion clinic is migraine and migraine headaches. And just as Jim said earlier, these are often people that have had some background of migraine in the past, either genetic or personal history, but it's much, much worse after their concussion, and clearly so. And so what do? Well, in my clinic, we give triptans, just like we would for any other migraine, sumatriptan, zolmitriptan, etc. We give a lot of NSAIDs. We give acetaminophen. We give tramadol. Rarely we give butalbital or short-acting narcotics. Those are things we try to avoid whenever possible. We try to avoid medication overuse, which can make things worse. And we try to avoid routine narcotics and take people off of routine narcotics if we can. We try to avoid routine butalbital, and we definitely avoid long-acting narcotics. This is an example where we think we can make people worse with some of these things, and other providers have made our patients worse as a result. But the way I'm drawing these things, you see these pizzas, these round blue pizzas that I've got up there. You notice that the pharmacology is drawn as 1/3 of the pizza, but the other 2/3 of the pizza are the non-pharmacological interventions. And so in the lower left side, these are all the lifestyle advice that we give patients and try to enforce lifestyle changes with our patients. And things like appropriate cognitive and physical rest, and ice and quiet and dark rooms and relaxation therapy and meditation. We spend a lot of time focusing on that. And then the lower right quadrant is what our ancillary therapists, our other medical professionals with whom we collaborate, are helping our patients with, are almost always referring to another provider who's going to provide additional care. And those are people that are teaching our patients relaxation training and meditation and biofeedback, for example, as a way to manage their migraines. Does that make sense? This kind of the basic structure of, you got pharmacological, lifestyle management, and other therapies. Okay, good. Questions right up front on this one? Yes, sure.
I constantly see patients coming into my office who are now 3-4 weeks post-injury, who've been taking NSAIDs on a daily basis for that time period.
Yeah.
Do you draw the line in terms of overuse, and what recommendation do you have for those who are using those medications on that regular basis?
Great question. So when do we draw the line of medication overuse? It's just exactly about right. 3 to 4 weeks, about a month of use of daily medications is about when we call it medication overuse. And if that's the case, if people are taking headache medications every day for 3 or 4 weeks, they now have a chronic problem, and they need to go on to the next slide, which is chronic migraine prophylaxis. Right on. So in that case, yeah, thank you. I'll slip you a 20 later. Perfect. No, in that case, clearly what they need is some prophylaxis. That the daily abortive treatments is really meant to be 3 times a week or less, not every day, or at least not every day for an extended period of time. And so migraine prophylaxis in the setting of concussive traumatic brain injury works really well. It works just as well, sometimes even better, than in the regular migraineurs that don't have traumatic brain injury. But the order of operations, the medications that we use are a little bit different, I find, than in regular migraine, those of you that have experience with migraine. We find amitriptyline overwhelmingly more effective than other pharmacological agents in the setting of post-concussive migraine. Whereas in the general population, I think topiramate is probably the most effective medication. We still use topiramate, but it tends to have more side effects in the concussion population than it is in the general population. So amitriptyline is our go-to drug for sure. But, you know, interestingly, recently, we've been going very early to botulinum toxin therapy injections because the side effects are really minimal, and we get a tremendous response to botulinum toxin. So after patients have failed their first 2 drugs, we're immediately referring them for Botox. We do use some propranolol and verapamil and divalproex and many other medications, but we're finding some of the ones on the lower part of the list there to be less effective perhaps in the concussive populations than in the general migraine population. But the key point is to avoid impairing side effects. Oftentimes the side effects in this concussion population in terms of mood instability and cognitive dysfunction are worse than they would be in the general population. So a medicine like topiramate, which can have real mood and can cause some real cognitive side effects at high doses especially, those are often worse in this population. Same thing with valproic acid. Can be okay in the general population, but I find more cognitively impairing in this population. Again, pharmacology is not the whole story. The non-pharmacological lifestyle of modifications, good quality sleep, we emphasize that really aggressively. Identifying and avoiding triggers like some specific foods and excess alcohol and erratic caffeine use and dehydration and specific patterns of lights and noises. We spend quite a bit of time trying to identify triggers that can then be avoided and eliminated. On the ancillary side, we refer a lot for cognitive behavioral therapy, stress reduction, physical therapy for concomitant neck injuries, and meditation training, and relaxation training, and biofeedback, again, as part of the treatment for chronic migraine, to change the patient's lifestyle and thinking about their migraine so that they have ways to avoid it other than using the pharmacology, just as you said, Jerry, so they don't have to do it all the time. Yes, please. Yeah, that's a great question. So we have several different biofeedback groups in the St. Louis community, and there doesn't seem to be a consensus about which ones are best. So maybe I'll try to answer that question next year. But right now I can't say which ones are. There's a wide variety of practices, as you probably know. There's a wide variety of practices. I have not yet seen one that was an obvious winner that was so much better than any of the others. Please.
Where do you inject?
So we're a very standard protocol, 25 locations around the head, and I'm not personally doing it, but our providers are doing 25 locations around the head, and in most patients, 2 or 3 chase the pain where they feel like they're getting the most pain. But it's a very standard, it's very similar to the published protocols. These are our migraine doctors who are doing it very similarly to what they would be doing for a non-concussive traumatic brain injury patient. Does not require, I don't think, any additional training other than an already headache specialist Botox trainee. Yeah, please.
What are your thoughts on the timing of the migraine prophylaxis, particularly in terms of the pharmaceuticals? That post-concussion, do you think that earlier is better, or if based on the course of recovery, or somebody has clear migraine-type presentations early, is that okay? What's your thoughts on that?
Yeah, so I never start prophylaxis earlier than 2 weeks after concussion. So I'm always waiting for them to have persistent migraines more than 2 weeks after their concussion. Because again, most of the patients are going to be okay within 7 to 10 days after their injury. The only rare exception to that would be somebody that had substantial migraine burden beforehand, it's just awful afterwards, and we know that there's a good chance that it's going to be awful. And a lot of times those patients had been on prophylaxis before, and we're going to either up their prophylaxis or get them back onto prophylaxis. But the most typical patient, honestly, that I see is somebody that has seen 3 other doctors, and it's a year out from their concussion or several years out from their concussion. So there's no question that it's going to be a chronic issue. But I have started prophylaxis as early as 2 weeks after concussion. Some of my colleagues think that's a little bit aggressive. Some of my colleagues won't start for 4 to 6 weeks after concussion. I don't claim that there's one right answer. I'm just telling you what we do. Yeah. Boy, there's a lot of questions back there, and I don't know who was asked first. So please, in the yes.
I was just wondering about visual rehab and vestibular rehab. Referred to that. Is that something you might value?
Oh, absolutely. So I've got a whole slide on vestibular issues, and we certainly do. I can't say that I have found vestibular rehab particularly helpful for migraine. So this actually, so I see your point though, the point of your question. Sometimes when people have intermittent vestibular concerns, one of the questions is, are they migraine auras that are manifesting as vestibular abnormalities? And you can do a vestibular rehab all you like. If it's a migraine aura, that's a chronic spreading depolarization running through the brain. That's not going to solve the problem until you've addressed the underlying pathophysiology. So we do refer for vestibular rehabilitation, but we want to make sure our therapists thank us for treating the underlying migraine first before we refer them to therapy so that they can actually benefit from the therapy. Oftentimes, if we put them through aggressive visual rehabilitation, we actually can make migraines worse sometimes, because those therapies are quite cognitively difficult. And they're very helpful, but we've got to address the migraine first to get the best use of the therapy. And that's where I think pulling together as a team really helps, doing things in the right order. Does that make sense? That's not exactly the answer to your question, but that's what we do. Yeah, please.
What are your thoughts on short dosages of steroids like hydrolase,
Yeah, so have I. And I didn't put that on here because I have not found that particularly effective in this patient population. I have definitely used that in non-traumatic brain injury patients, but I've not found it particularly effective in this patient population. There may be others who have more experience with it than I do, but that's not part of my common practice. Please.
Going back to medication overdose, what exactly is the physiological mechanism of Concussion?
Yeah, I wish we knew. No, I don't think we, yeah, I don't know. Does anybody else here know? I've never seen a good explanation for it. Please.
I know, I don't know.
Okay, good. Thank you. Yes, please. Oh.
So if somebody's coming into you and they, we see this a lot over or I do in my clinic, where people are coming in, they've had headaches for 3 weeks straight or 4 weeks straight, and it's just continuous and they're very migraine. But what they'll be referred to pediatric neurology and then they'll go through some variation, but it doesn't kick in the medication, does it, initially? And so what do you do in between when you're waiting for the amitriptyline, et cetera, to start being effective and a continuous headache, especially if it's people in school? And then, as an aside, I very often see a neurologist notes that they recommend Butterworth, and what's your thoughts on that?
Yeah, so what do you do during those first 4 to 6 weeks while the medication is becoming effective? That's where all those other things are go into play. Good quality sleep and learning how to avoid your triggers and learning how to avoid specific foods and lights and dehydration and the physical therapy and the stress reduction. That's when you start getting practice of all the other stuff. So to remember, the pharmacology is just 1/3 of the pie. If all you're doing is relying on that amitriptyline, you're only getting 1/3 of your meal. Right, you're still going to be hungry at the end. Butterbur, unimpressed. Yeah, unimpressed. Feverfew, unimpressed. Yeah, that stuff has an okay dose of vitamin P. Placebo? No, there are some randomized controlled trials that show that it has some benefit over placebo, but I have not been impressed in my own practice. Yeah, so yeah. Yes, please.
Question, amitriptyline is one of the only medications that we use in our clinic, but typically it seems like that's often brought into the picture when there's a sleep issue.
Mm-hmm.
So I guess I'm just wondering, do you find it to be effective if the patient is relatively sleeping well but still just having consistent headaches, not related to lack of sleep? Do you still see a reduction in those chronic migraines?
Yes, I do find that it's effective even in patients who are sleeping well. So I think that it's independent of the effects on sleep, and if we just treat the sleep, such as with Ambien or melatonin or something like that, that does not, in and of itself, have as big an effect on the migraine as the amitriptyline, in our experience. Yes, please.
So there are all sorts of headaches that come in post-concussion conditions, and silly question, but how do you differentiate a chronic migraine from all the other kinds of headaches that come in?
It's not a silly question at all. There are a lot of other types of headaches. There's a lot of tension headaches and neuropathic pain headaches and sinus headaches and trauma to other parts of the sensitive structures around the head and neck, and even occasionally cluster headaches that occur. The reason I focus on migraine headaches is that migraines are overwhelmingly the most common type and overwhelmingly the most disabling type. So the consequences of treating something that's not a migraine as if it were a migraine, and the answer is really oftentimes you can't tell completely, and oftentimes a patient can have more than one type at the same time. Okay, so the hallmark of a migraine headache is a unilateral throbbing severe headache that is accompanied by one or more of the following: nausea, vomiting, photophobia, phonophobia, or a neurological aura. And so a very large number of the severe headaches meet that criteria after traumatic brain injury. Now, there's no objective test for migraine, so that's just a definition. That's just our listed definition. So we can never be absolutely sure. But my point is that if you're not quite sure what type of headache it is, it doesn't hurt to treat it like migraine because it's the most important, the most common, and the most disabling cause. And there's not much harm in doing so, and a lot of potential benefit. So I'm often not sure, and I'll start a migraine prophylactic anyway if it's a disabling headache of an unknown type. And yeah, please. Yeah, carefully. So I start usually 25 milligrams once a day, and I've even given 12.5 milligrams very early. But I have in the past gone up to 100 to 150 milligrams of topiramate in some patients and tolerated okay. But on the other hand, I can just think of a patient that I saw the other day who we got him onto botulinum toxin therapy, and his headaches got much better, and we took him off of topiramate, and his cognitive function improved. So that was a really great thing to do, was get him onto the botulinum toxin so that he could get off of the topiramate. But then there's other patients, for example, who the topiramate doesn't seem to affect. I don't have a good way of predicting who's going to have cognitive side effects with topiramate and who's not. But recognize that it is a real possibility. Yeah, please. I think if you ask 7 neurologists about this topic, you'll get 8 opinions. No, and that comes back to one of my very first slides, which is that we don't have a solid evidence base. So we do not have like a standard approach to practice. So I think as long as we're open-minded and we make sure that we're quantitatively tracking our patient outcomes, and so that we can objectively say, okay, in this particular patient, what's working, what's not working, then I think there's room for exploration. The good news is that migraine headaches are not life-threatening, and so if you get the wrong medicine for the first 4 to 6 weeks, yeah, it's a drag for the patient, but it's not like the patient didn't die because you chose the wrong medicine up front. Yeah. They may feel like they're dying, but they didn't actually die. Okay, good. Well, that was good. Oh, yes, please. It's primarily focused on relaxation. Most of our biofeedback practitioners are focused on relaxation of the muscles in the head and the neck, and using some and getting some calming state of reduction in the stress response, which we think underlies certainly the worsening of the migraine, not maybe, if not necessarily the migraine itself. So they certainly tolerate. That's a good question. I don't know that I've seen any of our biofeedback practitioners focusing on that, but I'll ask though, and maybe I'll tell you next year. I haven't. Yeah, it's a good question. EMG based. Yeah. Please. Oh yes, I did not put acupuncture on there. We are just starting to use these slides are a little bit older. We are just starting to use acupuncture in St. Louis. We don't have a great community of acupunctuриsts in St. Louis area, but we are. I learned quite a bit about this from my colleagues in the military. So even in when I traveled a few years ago to Afghanistan, and one of their mainstays of chronic migraine treatment was acupuncture in Afghanistan. And so it's something that I personally haven't have enough experience with, but I'm excited about learning more. So do you find it helpful in this setting of chronic migraine?
I see more in the pediatric side, and I think when you put in the psychosocial factors associated with how often a person might have to go for migraine therapy, for acupuncture, it can put the family system out of whack, right? And also in terms of cost.
Right.
So if the family system is impacted, sometimes by some of these therapies, that cost-benefit analysis.
Right.
A lot of them, including the X, and I just wasn't sure what your opinion was on how effective that was as opposed to starting on it.
I don't have a lot of experience, and quite honestly, the thing that we're the most excited about these days is botulinum toxin, because we're getting the insurance companies to pay for it reliably now, and it's once every 3 months, and there's no persistent side effects. And so all the issues of do they take their medicines, are they compliant, and are they having side effects, are all just off the table. So it's very expensive, of course, but the insurance companies are paying for it these days. So it's not acupuncture, but that's the non-pharmacological part. Okay. No, but Keith Stussy, for example, Dr. Stussy in Afghanistan was using a lot of acupuncture and finding a very, very good effects in military personnel. All right, good. So turning now to the topic of insomnia, as you know, many concussive patients have major complaints with regard to sleep, and in our hands, we always try to use non-pharmacological methods to manage insomnia first. So I've got that a bit wrong on this slide. But so specifically, we are using some sleep hygiene and some controlled caffeine and moderate exercise and avoiding excess alcohol, morning bright light therapy using a light box to control sleep. But probably the most effective thing that we're using in our clinic is cognitive behavioral therapy for insomnia. This is really the big gun for insomnia, is CBTI. We have a very good CBTI clinic and some physical therapy for pain control. Sometimes nighttime pain and positioning are serious issues that are causing insomnia. And then occasionally we're getting new onset of sleep disorders, parasomnias and restless leg syndrome and obstructive sleep apneas and central sleep apneas and REM behavioral disorders, a new onset after a traumatic brain injury. And so a full sleep study sometimes is indicated in somebody that has a complaint of insomnia. But again, this is the non-pharmacological interventions come first in chronic insomnia in our hands. But if we do turn to pharmacological interventions, we usually will try melatonin first. I cannot say that it's overwhelmingly effective. We often have to go to something that's a little bit bigger gun, and Lunesta and Ambien are the two big ones. Lunesta is probably the one that I'm favoring at the moment because it's having less of the odd behavior than Ambien can have. And trazodone and Razorem are also reasonable medications. And in the really, really refractory insomniac, traumatic brain injury, concussion patient, we have had to use all of the above. So sleep is so important to the recovery from traumatic brain injury that we will pull out all the stops to get the patient to sleep well, because nothing else, many of our other interventions are not going to work until the patient starts sleeping well. So we really put a tremendous emphasis on sleep quality, and many of our therapists will tell us that their cognitive rehabilitation, their balance rehabilitation, their physical therapy rehabilitation is not taking, and then once we start to fix the sleep, then it starts taking. Then they start to make progress. So this is the team dynamics here. We avoid neuroleptics. I can't tell you how many people I've seen coming to me on Seroquel for sleep, which I think is harmful in terms of the recovery of the brain from injury. We also avoid excess alcohol as a trigger for sleep. We take a careful history. Some of our patients are using a bottle of Jack Daniels every night as their sleeping pill. That probably does not improve the recovery from concussion. But if you don't ask, you won't find out. We also avoid anticholinergics. There's a misperception in the general public, I think, that just because a medication is over-the-counter, like Benadryl, that it's safe. And in our hands, we find that the anticholinergic over-the-counter things like diphenhydramine, Benadryl, that's in most of the popular over-the-counter sleeping aids, is probably less effective and also has more side effects than the prescription medications. So we get our patients off of that stuff, and I would rather prescribe them Lunesta rather than having them take Benadryl, for example. Yes, please. As short a time as possible, but we don't take them off if they still need it. So it's not a very good answer, but I've had patients who have been on these medications for years and have not had, even though that's not the way they're FDA indicated, they're indicated for short-term use, we've had them on there for years without any obvious long-term side effects. So typically I'll have the patients do a course of cognitive behavioral therapy for insomnia. If they need a medication in adjunctive, we'll do that. as they start to get really good at their cognitive behavioral therapy for insomnia, as their therapist tells me, oh, she's really good at it now, he's really good at it now, then we'll try to withdraw the medication and see what happens. If we withdraw the medication and they still don't need it, then we put them back on the medication. Because again, as I said, sleep quality is so important that I would rather them be sleeping. My longest term insomniac patient has been on meds for insomnia every night for something like 12 years. And he's alternating, going every other night, Ambien one night, Lunesta the other night, Ambien one night, Lunesta the other night. Has not had any long-term consequences of that. Now, I'm not saying that's a good idea for everybody, but he was much, much worse when he did not take his sleep meds. So it was worth it in this case.
If you have questions, let us catch up to you. We have handhelds now that we can make it easier.
Yeah. I saw a question. Yeah. No?
I have a patient who's a medical student, and she's taking Benadryl, and she's up to quite a bit of Benadryl at night, combined with Klonopin.
Oh.
It sounds like a very dangerous combination.
I think those are in the avoid list. Benadryl and benzodiazepines.
She's obviously self-medicating, but you know, she has a long history of severe insomnia.
Yeah.
So always has been.
No, that's a really tough, those patients like that have a really tough, long history of insomnia, that's where cognitive behavioral therapy for insomnia is really the only, that's the mainstay of treatment. Because this is not fundamentally a pharmacological problem. Fundamentally, it's a behavioral problem. And so that's where I think is the number one domain. Yeah, please.
Have you been able to track a proportion of those having new onset kind of insomnia problems versus those like pre-morbid in your clinic?
As a proportion, it's hard to say because my clinic is over-enriched for the unusual and severe and refractory. So take it for what it's worth. Most of the patients that I've seen have had a pre-existing some history of insomnia, which has gotten much worse after their injury. I would say that's the rule.
So my question is, kind of related is, what is the difference in the rate of people with O or maybe more psychological coming into your clinic with chronic insomnia or chronic migraine?
Oh, yeah, absolutely. So insomnia is so comorbid with anxiety and depression that we're very frequently treating them all together. So, there's always this question of what do you treat first, the psychiatric condition or the neurological condition? The answer is both together. They don't really get better unless they're both treated together. But yes, there's a high base rate of anxiety disorders and depression in the people that have insomnia. But sometimes the insomnia is something as simple as just bad habits that they never learned properly, and sometimes it's something like it's really actually a pain issue. That as soon as you treat the pain, the insomnia gets substantially better. So you have to dig into this. This is why these initial office visits take an hour and a half a lot of the time. Yeah, please.
Let me ask you a question kind of tying in the insomnia with the headaches. Which is that how often do you find patients waking up in the middle of the night with headaches, both in a concussion population or in normal population?
Yeah, so it's not common that people wake up in the middle of the night with headaches, and it's a red flag. So as a neurologist, if somebody wakes up with a headache in the middle of the night, I'm going to look very carefully for another cause other than migraine. I mean, it does sometimes happen in migraine. Sometimes we don't find another cause. But most migraine headaches come on later in the day with cognitive activity, and they get better with rest and sleep. If the patient can sleep, sometimes that's what it takes to get rid of the headache. If a patient has that, I'm going to look carefully for, or a headache that's worse lying down than it is standing up. That's also not typical of migraine. Most headaches get better when you lie down and worse when you stand up. So if it's worse lying down or awakening, I'm checking for another neurological problem. And
would concussion possibly be that? I mean, do you find that
No, not concussion. I'm looking for something other than migraine and other than concussion in that setting. Now, it's true that even though the incidence of a process that's raising intracranial pressure is very low, and the atypical presentation of a common illness like migraine is still more common than the typical presentation of an uncommon illness, even so, I'm still going to look for that uncommon illness. I'm going to look at the back of the eyes, and I'm going to do a careful neurological exam, again, even if I've done one before. And I may be sending that patient for an imaging study of the brain, even if they've already had one, if they have new onset headaches that are waking them up in the middle of the night. Yeah. Please.
Other than these things not working, what are your triggers for ordering a sleep study?
Triggers for ordering a sleep study, for example, would include severe refractory fatigue, such that even if they're getting enough sleep at night in terms of hours spent in bed or hours spent nominally asleep, but they're still not getting refreshing sleep, that's what's making me think that maybe they have a sleep apnea or a restless leg or a parasomnia. Or any symptoms that are concerning for narcolepsy, cataplexy, collapsing, for example, or sudden attacks of sleepiness during the day, that triggers a sleep study right away. But the most common reason that I'm ordering a sleep study is daytime fatigue. People who are exhausted, that all the normal routine, all the normal mediations for fatigue that we do are not working. Yeah. All right. Okay, attention deficit. This is, sorry, yes.
I know that in a lot of athletes, if you take them out of play or out of their game, sleep is really easily disrupted no matter what kind of injury they have, whether it's a brain injury or a limb injury. So are you using any sort of mild or gentle exercise to help with the insomnia?
Oh, absolutely. So exercise withdrawal is a major cause of insomnia. And I think I've got that actually on line number 3 of the left lower quadrant, moderate exercise. So I prescribe moderate exercise for these athletes. And I order them to do it. I actually write it out on a prescription pad. 30 to 60 minutes of moderately intense exercise, 6 days a week, whether you feel like it or not, as a prescription. And I send them to the physical therapist to find something that they can do with their injury. And I have them work with a personal trainer to find something that they can do so that they don't overdo it. But yes, I prescribe exercise for athletes because I think exercise withdrawal is a substantial cause of insomnia and anxiety disorders.
In the case of concussions, how soon do you start that?
Well, so typically I'm not really seeing them for at least the first 2 weeks. So I'm usually the second or third person that they see. They've seen a sports medicine doc or a primary care doc, and the people that are refractory to the first line normal therapy are the ones who get to see me. On the rare occasion that I'm seeing somebody front off, if it's a called in special favor, I'm having them start very small amounts of exercise on the second day and then a little more on the third day and the fourth day, and I'm doing exactly the classic ramp up in their exercise during the first week. But yeah, this is the 2 week or more mark, and quite honestly, a lot of the patients I'm seeing are 6 to 12 months or more out from their initial concussion or concussions, and they've had a long spell, and we're rehabilitating them. We're treating their deconditioning as much as anything else. All right, good. So attention deficit. This is probably the most common cognitive dysfunction that I see in concussion patients. Many patients who have pre-existing attention deficit, it's substantially worse, and patients who have not had a history of attention deficit diagnosed prior to their injury can have new onset attention deficit. And it's in all ages. I've seen new onset attention deficit even in middle-aged or elderly concussion patients. So it's not just kids. So an attention deficit is both one of the most gratifying things to treat and also a little bit one of the most scary things to treat. And this is where, and again, I'm going to say this as a caveat, the pharmacological aspects of attention deficit treatment are very controversial. There are many people who think that what I do is a little bit of a cowboy behavior because I give a lot of stimulants. I treat very aggressively with stimulants for attention deficit. But nonetheless, there are also quite substantial non-pharmacological approaches to treating attention deficit. Cognitive rehabilitation and meditation training are helpful. Environmental distraction control, cardiovascular exercise, as we discussed, stopping use of alcohol, good quality sleep, meditation and diet can be very helpful with regard to treatment of attention deficit. Nonetheless, Overwhelmingly, the most effective treatment for attention deficit are the direct stimulants. This is Ritalin and Adderall and Vyvanse and a wide variety of other preparations. These when used properly can be life-changing for patients that have disabling attention deficit after their concussive brain injuries. We also use caffeine as a stimulant. We prescribe specific approaches to using caffeine. It's the oldest stimulant in the world, and it's very effective if used exactly right. We use Strattera a little bit. We've not been particularly impressed with Strattera in concussion. Modafinil, people ask about modafinil a lot, Provigil. Modafinil is a wakefulness promoting agent. If the problem is the patients are falling asleep, then modafinil is very helpful. But if they're wide awake but can't pay attention, modafinil is really not that helpful in our hands. Donepezil and rivastigmine, the acetylcholinergic acetylcholinesterase inhibitors, have a small adjunctive role for attention deficit. They can have a small benefit in addition to a stimulant or in a patient for whom a stimulant is contraindicated. But here, let me tell you, the really important thing is that stimulants are not for everybody. Stimulants are contraindicated in people who have active coronary artery disease, active cerebrovascular disease, uncontrolled anxiety, uncontrolled migraines, uncontrolled psychosis, very severe weight loss. They can be used safely in a very large number of patients, but not in everybody, and they are truly contraindicated. They can be truly harmful if used in the wrong patient population, and if they're overused or misused, they can also be truly harmful. So they're like a two-edged sword, really effective and real potential for harm. Yes, please.
Without people who are presenting with any type of seizures, what about the use of bupropion or Wellbutrin? I see a lot of that coming into the clinic as well for my sports physicians.
For specifically trying to treat attention deficit.
And possibly, it's usually comorbid with some type of mood issues.
Yeah, because I've seen those treated for mood issues, but I've not seen that used for attention deficit, bupropion, so much. I mean, it's possible that there's a literature that I'm not aware of, but I've not done that. Except, I mean, for mood, yes, I hear what you're saying. Yeah, please.
Can you talk a little more about how you use caffeine? I work with a lot of collegiate athletes who, if those types of medications would be helpful at their NCAA athletes, you can't just start Strattera or Adderall or Ritalin, without documentation and testing and things. So other strategies like caffeine, if you've already used the behavioral strategies, something like that would be really useful.
Yeah, no, absolutely. So I totally hear you. So the key, the way I've used caffeine typically is have them use a first slug of caffeine, whatever that turns out to be, 12 to 16 ounces of regular coffee first thing in the morning, and another one right after lunchtime, but then no caffeine after more than 8 hours before bedtime. And I have them use caffeine 6 days per week, not 7, so that they always get one whole decaffeinated day, which prevents them from getting tolerant to it, which prevents them from tachyphylaxing to it. And now everybody's tolerance to caffeine is different. Some athletes, some individuals, a small coffee, a 6-ounce coffee, for example, or a shot of espresso, which is 50 milligrams of caffeine, as opposed to a big coffee, which is 100, 150 milligrams of caffeine, is the right amount. And then some people really do require more than that. And so it's not wrong to be using 4 to 6 caffeinated drinks per day, as long as there's none within 8 hours of going to sleep, and as long as it's 6 days per week, not 7, and 51 weeks a year. I also recommend that my patients take 1 whole week off of caffeine each year. I do that myself, and it's painful, but it's actually very helpful in terms of keeping one's tolerance for caffeine. Because caffeine, the problem with caffeine is that you just start using more and more and more of it because people get tolerant to the effects. So it has to be done carefully to avoid that. Yeah, please. Yeah, I think so.
Given the expectation for relative quick recovery in a mild concussion, are you prescribing these medications short-term or long-term?
These are all, let me unpack your question about, given the expectation of quick recovery for mild concussion. So I don't see anyone with mild concussion. People that have mild concussion and quick recovery, I don't even see them. So these are all people that have not had quick recovery, and these are all people that have not mild concussion. So I don't use any pharmacology at all in people that have mild concussion. So yeah, does that answer your question? And so sometimes these are short-term use, and sometimes this is lifelong use. Sometimes this is 6 to 12 months, and let's see what happens. But as I said, I've had patients who've been on stimulants for years with no long-term side effects as long as they're used properly. Yeah, so mild, well, I'm just going to give my biases here. The definition of mild is soft or gentle. So my patients don't describe it that way. They find that as a pejorative term to call it mild. If you call it mild, they find that insulting, to be honest, because this is not mild. This is changing their lives. There are people, but again, I don't see the people who are fully resolving within not 7 to 10 days. They never come to see me. So these are substantial concussions, the people that I'm seeing. We may have another talk. I don't think there's any role for pharmacology at all in people that have the true mild, fully resolving terms. Does that make sense? Yeah. Okay. Yeah, please.
Given that you're in a protracted recovery clinic, as you've said a couple of times now, how many patients do you see with attention deficit symptoms that are potentially borderline, maybe conversion symptoms, conversion cognitive symptoms, or family discord, getting out of school, sort of maybe somaticizing, that kind of that nature?
Yeah, boy, that's a tough question. Well, first of all, there's no way to tell for sure who has a conversion symptom and who doesn't, right? There's no gold standard test. I would say that probably a third of my patients have some potential for secondary gain. Either they would like to get out of school, or they'd like to get out of work, or they have a workman's comp case, or I've done medical legal cases. But most of my patients really would like to get back to their lives and like to get back to what they're doing. So I've probably prescribed stimulants for about 200 patients, and I've had to fire 2 of them because of abuse of the stimulant medication, and I've probably had 10 or 15 that I thought for sure were malingering or trying to get out of something, or having some secondary gain as the primary driver of their symptoms. So that's just my opinion. I can't say how many of the rest of them were fooling me, but nonetheless, I don't want to withhold something from patients who really need it because I'm afraid of giving something to somebody who might not be, may have more than one thing going on. Do you know what I mean? You know what I mean? These are, as long as they don't have contraindication, as long as there's no contraindication. If there's a contraindication, then I'm not gonna do it. But this is the controversial part. This is where people call me a cowboy. Is that I may be prescribing stimulants to more people than actually need them. But I'm okay with that because I can't really tell who those people are. So if you have a great way to figure that out, I'd love to know.
Just to perseverate on this a bit more, because we have difficult decisions about what to do with people who have, let's not even use mild, a concussion,
right,
who isn't recovering in an expected way, and we then have to come in with other non-neurologic etiologies sometimes to figure out what's going on. But I think what I'm hearing you say is that you treat people kind of regardless of etiology as long as there was some concussive event, but it could be a mood disorder or, a migraine disorder. But when we're dealing with athletes and making decisions about return to play and how to maximize their potential to return to play without hindering their neurological status, this gets really, really tricky. So I think it's important for us to have a better feel for the kind of person that you're seeing so that we don't carry away the message that this is a typical kind of post-concussive response. This is a aberrant but real. It's real, but it's not necessarily a neurological or brain-based response. Is that fair?
Okay. So so first of all, these are not typical. That's absolutely true. So I would probably say that only 10 to 20% of the people that have a simple concussion fall into this category. But increasingly, we're seeing people that have had 3 to 100 lifetime concussions, and they're commonly represented in this group. Increasingly, we're seeing people that have had a prior history of attention deficit or migraine or mood disorder who then have a concussion, and this worsens their pre-existing condition. So in that sense, I agree with you. This is not the majority of patients. This is, as I said, I think on the very first slide, the grand majority of patients, no pharmacology is needed at all. But then I am going to take, so I'm agreeing with you on that point. But I'm going to take issue with you when you say that it's not brain-based. It's all brain-based. There's nothing else it could be. Unless you have a dualist view of the world. But it isn't necessary. We don't know for sure whether it is due to this specific concussion or whether it had something to do with their early childhood or their genetics or the 3 other previous concussions that they may have had or their history of alcohol abuse or their sleep deprivation or their stress with their girlfriend, which has a big influence on their hypothalamic pituitary axis and affects the structure of their, the chemical structure of their brain. It is the brain, after all. So that's right. I can't untangle that. Nobody can. But I'm still going to try to help my patient get better.
By brain-based, I don't mean that there isn't a brain component, but what is the key etiologic factor? That's all.
I'm agnostic about that. And I don't think it matters. I think we treat our patients, we help them get better, agnostic to etiology. And I tell the lawyers, I'm going to help the patient get better, but I'm not going to be able to tell you the cause. Yeah, please.
So a lot of the patients that are referred to our clinic have seen, say, the pediatrician or somebody else, their family practice doc, and if they had pre-existing ADHD and were on stimulants, the physician has pulled them off their stimulants immediately post-concussion to let their brain recover. Now, of course, they come in on top of having a concussion with all the post-concussion issues. Now they're off their stimulant that they take every day, and they're having a horrible time concentrating.
Imagine that.
Yeah, it's shocking. What would you tell? What would you tell your patients about continuing on their regular stimulant medication that they had been prescribed normally, even immediately post-concussion?
The question of how long to rest after concussion is really, really controversial. Many of us were at a meeting in Pittsburgh recently where the discussion about length of rest was raised, and shorter and shorter rest periods are now being advocated. And so I can't tell you the absolute scientific answer to that question because there is no scientific answer to that, but I have patients go back onto stimulants as soon as I see them, which, as I say, is usually a couple weeks. I've been in that situation too, where they were taken off their stimulants, and I've usually told them to go back onto their stimulants. I don't really know what the best answer to that is. A period of rest is probably a good idea, but how long that period of rest is hasn't been addressed, and whether you should start off with a small dose of the stimulant and ramp back up over that first week, I don't know. But I hear what you're saying. It's a tough one.
Is there harm to putting them back on the stimulant after?
Not that I've ever seen. I mean, the only question would be whether there would be harm. In my mind, the question would be, is there harm to putting them back on the stimulant in the first 24 hours? And that I would be a little bit concerned, I guess, about that. Because we do usually recommend that people rest for 24 hours. But again, we don't have a firm evidence base for that. Yeah, I don't know.
We feel strongly there's harm and risk not.
Yeah, but how soon is right back on? Like immediately, same day? Not even 24 hours.
Well,
Yeah.
you're talking about G protein receptors that are modified over weeks and weeks. But the point being, they're already sad because we're supposed to acute dopamine withdrawal on top of everything else, and they do compulsive things that cause their body.
Yeah, well, that's an interesting point. So, yeah, we'll have to think about that a little bit more. I don't have a good answer. Yeah, please.
Can you comment on the use of amantadine? So, not necessarily for ADHD or attention deficit, but I see physicians using it a few weeks out for
cognitive capacity, fogginess, attention problems, and then some use it just for a couple weeks, some keep kids on it for months.
Yeah. So I've been in concussion patients, I've been pretty underwhelmed by amantadine. I've put lots of people on amantadine. I've never seen anything happen. Unlike the stimulants where it's crystal clear that something happened, might be good or might be bad, but something happened. So the amantadine data is as follows. In patients with very severe traumatic brain injury, meaning that they were still in a state of reduced consciousness at the time that they were admitted to the inpatient rehabilitation facility, then a randomized controlled trial of amantadine showed that their recovery of consciousness was a little bit faster on amantadine. And then when they stopped the amantadine after, I believe it was 6 weeks or something like that in the study, the other patients caught up. So it was rather of a rate of recovery of consciousness. And so then from there, the amantadine has then been extrapolated to all sorts of cognitive concerns with regard to traumatic brain injury. So yeah, it's not part of my. The only times that I've used amantadine and thought it had some benefit was for fatigue, but and that's been known from the multiple sclerosis literature for quite a while in the setting of fatigue. But I find amantadine pretty underwhelming. It's pretty safe, though. All right. As if this is even more fun, let's get into a really controversial topic. Mood instability. This is one of the hallmarks of people with refractory concussive disorders is mood instability, where they're really, this is oftentimes what their families complain about most, is that patients are moody. Their mood regulation is not the same as it used to be before their injury, and it can be persistent. Again, cognitive behavioral therapy is probably the best treatment for mood instability, and this is what we go to first if we can. Sometimes the mood instability in some of my most extreme patients can be so severe as to be life-threatening, dangerous to themselves or others. So we've admitted patients to the hospital because of mood instability, a psychiatric hospital, because of mood instability that was new onset after concussive injury. This is what everybody worries about, right? In a retired athlete who's had multiple concussions, is that they're going to do something dangerous to themselves or others because of dysregulated mood. And so it is not bad. It's not wrong to just say this is dangerous, that you need to be admitted to the hospital. Don't be afraid just because you're not a psychiatrist with admitting privileges to say this patient needs to be admitted to a psychiatric hospital. This is about judgment. And so I think it's, as I said, I think it's dangerous to continue treating a patient when they're as an outpatient when there's a risk to themselves or others. But then again, hopefully we can get our patients to the point where that never gets to be a risk. We can prevent them from becoming dangerous to themselves or others. Cardiovascular exercise, stopping alcohol. I think in patients that have severe mood disability, dysregulation, I don't think any amount of alcohol is safe because one leads to too many. Good quality sleep and meditation can be helpful adjunctive non-pharmacological parts of treatment for mood instability. But again, in people that have severe mood instability, and I'm going to emphasize this is a rare, small subset of the concussive population that I see in my patients, but you all see a few of these too. If you see 100 patients, you'll probably have one that has really disabling mood instability. And so then we are using pharmacological management in addition to the non-pharmacological tools. The two drugs that I use the most are lamotrigine and oxcarbazepine. These are two anti-epileptic medications that have well-known mood stabilizing properties, and importantly, relatively minimal cognitive side effects. Unlike some of the other mood stabilizers, such as lithium or atypical antipsychotics, propranolol, carbamazepine, which can have more side effects than Lamictal and oxcarbazepine. These are the ones that have the least effects on cognition, weight, and headache. So Lamictal, you guys are familiar with Lamictal. The tricky part about Lamictal is that it takes so long to titrate. It'll take about 2 months to get a patient up to full therapeutic dose of Lamictal. So in an urgent situation, Lamictal is not a great choice. So oftentimes I'll start oxcarbazepine first if there's a more urgent issue. Trileptal is it can be effective quickly. Just have to draw sodium levels to make sure that it's not causing hyponatremia, and getting patients into cognitive behavioral therapy and stopping alcohol and getting exercising and a good quality sleep, et cetera, for the mood instability. So I do think these are effective. I've had patients who were able to, this was the issue that was preventing them from returning to play or returning to school or returning to work, was the mood instability, and we've had patients been able to return to those activities once we had appropriate management. One of the mistakes that I see is people who have erroneously think that what they're seeing is depression when in fact it's mood instability. Depression, the characteristic of major depression is that the mood is low most of the time persistently. Whereas mood instability, it's not that the mood is low persistently, it's that it can be very low, but it can also be too high, and it can fluctuate, it can be overreactive. It's life circumstances happen and the person overreacts to it. That's the characteristic of the mood instability. And so I think it's a mistake to treat it as major depression if in fact it's mood instability. Antidepressants are not as effective for mood instability as mood stabilizers. No surprises there. I'm a neurologist, but I'm still comfortable doing this, even though this is usually what most people think of as the domain of the psychiatrists, is treating mood instability. I don't think this is rocket science. This is the SSRIs made depression and anxiety treatable by non-psychiatrists, and I think Lamictal and oxcarbazepine make mood instability treatable by non-psychiatrists also. Ooh, I was expecting like a gazillion hands all of a sudden, because this is actually one of my most controversial slides in some audiences. All right, well then, I've beat you all down. Nonetheless, Ruben, how long do we have, by the way?
5 more minutes.
Okay, perfect. Nonetheless, despite the fact that not everybody who has a mood disorder has depression, there are people who do have real major depression after traumatic brain injury. I've heard it described as like having a dementor in the room by a young teenager during the Harry Potter era. So like really bad depression, like seriously awful, the worst thing that you can possibly imagine, depression after their brain injury. And these were patients that don't all have a prior history of depression. Again, it's not common. This is a small subset of traumatic brain injury patients, but be aware that this can happen. The non-pharmacological options are really important. Again, you're seeing these over and over again: cardiovascular exercise, sleep, meditation, avoiding excess alcohol, cognitive behavioral therapy, supportive therapy, inpatient hospitalization if they're dangerous to themselves or others, good quality pain control, and training in meditation, training in relaxation, biofeedback for depression. But if necessary, serotonin-specific reuptake inhibitors can be just as effective in a traumatic brain injury patient with depression as in any other patient population. We use all of them similarly, sometimes adjunctive mood stabilizers. Sometimes, interestingly, stimulants can be a good adjunct to major depression treatment if the patient has a very lethargic, low-energy depression. Sometimes we'll use an activating antidepressant like fluoxetine and a small dose of a stimulant like Ritalin in that patient population. Occasionally we'll use a small dose of an antipsychotic, rarely I would say, in truly refractory depression. We have a randomized controlled trial that's starting at Washington University of transcranial magnetic stimulation for refractory depression after traumatic brain injury. We think that it's, we've treated a few patients and found that to be effective. I didn't put that up here, but that's something that's cooking. We even had one patient that required ECT after her traumatic brain injury. That wasn't a concussion, that was a more severe injury. Okay, anxiety and post-traumatic stress disorder. I work a lot with the military, and since I started working with U.S. military and seeing our U.S. service members who are injured in the wars in Iraq and Afghanistan coming back, post-traumatic stress disorder was a virtually ubiquitous comorbidity with their traumatic brain injuries. Once my eyes were open to post-traumatic stress disorder, I started seeing it everywhere. I started seeing a lot of civilians with post-traumatic stress disorder. If you ask the right questions, you'll find a substantial number of people have flashbacks and re-experiencing and avoidance behavior and emotional numbing after their traumatic brain injuries. And so we think that there's a role for treating post-traumatic stress disorder in some of these patients. And again, cognitive behavioral therapy and prolonged exposure therapy are the mainstays of that treatment. But if pharmacological treatment is required, the anxiolytic SSRIs like paroxetine and sertraline are helpful. Prazosin is helpful for nightmares. If a patient is having disabling nightmares, waking up at night, maybe not from a headache, but actually from a horrible nightmare related to the sport injury or the car crash or whatever it was, then prazosin is helpful in that regard. Short-term benzodiazepines are sometimes helpful in this regard. This is the only circumstance, disabling PTSD or anxiety are the only circumstances where I think benzodiazepines can be helpful, and then only short-term. And again, mood stabilizers and very rarely antipsychotics. We try to avoid levetiracetam. Some people get put on Keppra for risk of seizures, or put on Keppra if they think they're as a migraine prophylactic occasionally. We try to avoid that because that's mood destabilizing. And I should have said that on the previous slides as well. That can be destabilizing in patients with other mood disorders as well. So we do take people off of Keppra quite a bit and put them onto other agents if we think that's the issue. A controversial point here is that for a long time we've believed that stimulants were automatically contraindicated in patients with anxiety or post-traumatic stress disorder, but the recent experience from the military is that that's not the case, that their post-traumatic stress disorder does not automatically worsen when they're put on a stimulant. So if the stimulant is really indicated, give it a try and just watch them carefully. And if their PTSD and anxiety gets worse, well then it obviously did, but a lot of times it does not get worse. It actually could actually be helpful for their other issues regarding attention deficit. All right. And this is the last treatment slide, and then I'll wrap up. Fatigue is really important and can be quite disabling in these refractory, unusual traumatic brain injury patients, and I actively treat fatigue. If the fatigue is the actual limiting factor. Now, of course, before I'm treating fatigue per se, I'm checking to make sure that it's not a sleep disorder or that it's not a mood disorder or that it's not an issue with alcohol use. So, but if not, then gentle reinstatement of cardiovascular exercise under supervision, so that no matter how tired they are, to gradually treat the deconditioning aspects of fatigue. With cardiovascular exercise, cognitive behavioral therapy, and insight-oriented therapy. Sometimes there's an unrecognized mood disorder. And avoiding sedating medications. Surprisingly, people who are very fatigued and they're taking Benadryl every night. Well, yeah, no surprising they're fatigued in the daytime. And avoiding withdrawal from stimulants. Again, no surprising if somebody is withdrawing from their stimulant that they're fatigued. But in the really disabling fatigue cases, I will treat with direct stimulants and caffeine and amantadine and modafinil and fluoxetine and venlafaxine for the fatigue itself, explicitly. Now, it's not easy to get insurance companies to pay for some of these things because fatigue is not an indication, it's not a disease, it's a symptom. But nonetheless, I think this can be quite helpful. So I'm going to wrap it up and give you the bottom line again. The bottom line again is most patients with concussions do not require any pharmacology at all. So I don't want you to come away with the idea that Brody treats every concussion patient with pharmacological treatments. Most patients do not require any pharmacology. Nonetheless, if your patient does require pharmacology, there is quite a big bag of tricks that can be used that can actually be quite helpful. But in every case, the pharmacology is an adjunct to the lifestyle management and the non-pharmacological therapeutics that are used in these complex sequelae. There are no pharmacological cures. None of these diseases are cured, but they can be very helpful if used properly, and some pharmacological agents are harmful and should be withdrawn. And the best thing you can do is to get your patient off of some of your drugs in a lot of cases. And then finally, the last bottom line is that everything I said just now is just my opinion, no more. Do not think of this as an evidence-based field. It is not. Thank you.
Okay, at this point, we're going to take a break There are going to be some refreshments outside, give you a chance to relax and mingle.
Hello? All right, so we have a quick break. Those of you guys that have posters, go ahead and put them up right now next door. The number corresponds
multidimensional anisotropy brain imaging. It has sufficient sensitivity to find those localized patches of damage. The fact that we can see it that early indicates that potentially, I don't want to stick my neck or any other part of my anatomy out too far here, but it needs to be acknowledged and acted upon. There's a very real chance that the earliest impact of the heads plant the seeds for CTE, and it's simply how exactly propagates over time we don't know. But if you're privy to the knowledge that it can start that early and choose to do nothing, or say, oh, we have to research that for 5 more years, someone please give me several hundred millions of dollars to do that. That's no way to treat our young athletes or our men and women in uniform.
Well, I really appreciate the balance that you're presenting of we have all the research, we have some things that we know exist. Exact cause isn't completely, scientifically put out there for everything, and we know enough. We know enough to start doing more than we're currently doing, and I think that at times that part of the argument or that part of the advocacy from the scientific community isn't always, we kind of get caught up in the trees as opposed to the forest of we know enough to start doing more than we're doing. Absolutely.
Right. And if we're simply pretending to need to know more to continually to fund research that's reinventing wheels from 30 years ago, that's also a very inefficient use of those funds. We can find far better ways to deploy that money directly, again, to meet the needs and make life safer for those young athletes. The 20 million young athletes, not the handful in a clinical study here or an assessment program there. But the high volumes and again, hundreds of thousands up to a couple of million men and women in uniform across all the forces.
Well, as a member of the military, I appreciate that. I kind of want to go back to a little bit more about what X2 does product-wise. I was noticing some pretty fancy tablet-based app-type things. You can talk a little bit about that.
Yes, at the end of the day, the devices that are measuring head impacts, as well as the neurocognitive tool that's putting a baseline on an athlete at the beginning of the season, looking at how that changes post-impact, generates a lot of data, and our business is rapidly evolving into a healthcare data analytics business. We currently sit on the world's largest database of direct head impact records, going on 6 million, and as we begin to dig into that data using a variety of advanced data analytics techniques, there are some very, very clear patterns that emerge, and they're beginning to give us the power to take each impact as it happens, bounce it off that large database, and make much more accurate, much more precise. Today, focus on risk reduction, but tomorrow at some point also much more accurate and powerful diagnoses as well. So what you see on the tablets are the first versions of those products where we're crunching the numbers and making immediate recommendations about, okay, based on what just happened, you're good, you're safe, keep playing, have fun. We go a step further and say, and in fact, you're getting the lowest impacts of anyone in your team. So throw in it's a little bit of competition is good to get people focusing on
technique,
right? You'll see in our iPad demo these images that get generated of a head with a sea of arrows from all around it. We have a growing number of young high school players who look at that and chastise their colleagues for being the unicorns in the crowd, the guys that keep on having cluster of arrows protruding from the forehead of their helmet, right? Because they can't get their helmet out of the way when they tackle, and being a unicorn is bad. And we've got a bunch of 16 to 18-year-old kids. They're having pictures in their head of how to play safer, right? And beating that into their fellow athletes, that's only good, right? And so unintended effects, we find that in many teams, particularly youth in high school that use our products, it creates a whole new level of camaraderie between the players and their overworked trainers and coaches, many of whom are just volunteers. And they love the game and they like to be out there, but let's be honest, it's like parents and their own kids. It's sometimes hard to get inside their head. And sharing this data has proven to be just a phenomenal social bonding experience for young athletes and their coaches.
And what matters is not just the sharing of the data, but how you share the data.
Yes. Yeah. So we pay a lot of attention to all the issues around usability, how we present it, when we present it, and having a very, very simple, clear path to acting on it, making the data actionable.
Okay. Well,
so as an athletic trainer practicing at a high school, give me the basic of this is the first time I've seen it, so give me the basics of what it is, how it works, because my primary audience listening is athletic trainers.
Yep. So you line the players up, you put the little wearable sensor behind their ear, your iPhone or your tablet device brings up the team. You see all of the athletes who are logged into the system. You see all the devices. You can make sure that each player has a device actually assigned to them by name and number. If not, you can quickly assign. The devices are sitting in idle mode. You can now activate them, at which point they're starting to use up a little bit of the precious battery power, and they're going to start recording impacts. And you can simply let it run and gather all the impact data, and at either halftime or the end of the game, as the players come back in, those devices have Bluetooth connectivity. They automatically sync. They dump the data. The data goes up in the cloud, and you immediately get an alert back, and you can choose how much information you want. But the basic alert is all your players are good today, or the following players accumulate enough impacts that you want to put them through. You've already got a baseline neurocog. Run it again. Take 8 minutes. Rerun it just to make sure that there are no observable changes in the neurocog behavior. Or it'll tell you if one or more players had either a single impact or an accumulation of impacts in this most recent session, or the ones they received today put their accumulation for the last week, the last month, the last season over a threshold where if your primary interest is, as it should be, the athlete's safety, they should be sent to see a doctor. So removed from play, and under the youth concussion safety laws that we have in the books in all 50 states now, when you make that assessment, they should be removed from play. There's a risk of injury due to head impact. They can't return that day anyway. They need to be cleared before they return to play. So it's, in the report, you hit a button, send to parents, send to doctor, so that you've done your part. The information is passed on to the people who are going to make the decision, and you'll find by the end of the first season doing that, serious impacts will have declined 30 to 70% in your athletes.
All right, so when you send it to the doctor, we have a problem with kids going to some emergency rooms, and it just seems that they don't have a good idea of how to deal with concussions. So do they have to go through a certain training to be certified for the X2, or is there a report saying this, or is there a certain, what's the best way to get them cleared from a doctor? Because if I send a kid to a doctor saying, hey, you had enough impacts, you need to go see a doctor, well, they're going to go to the doctor down the street and they're like, well, do you have any problems? No? Okay, we'll go back to playing.
That is it's a very real problem. It's one, unfortunately, that we're not in a position to address directly, but this organization, the
Sports Neuropsychology Society.
That's right. If you look at the flyer they actually included with everyone's registration, they will point you to a registry. Find a doctor trained and certified in handling concussions in your neighborhood. Go to that link, and that's one of the great services that this organization is providing. We need more of them. They need to be better at it. I mean, we all know where to find it. If you chip a tooth, you have no problem finding a dentist, right? You get a whack to the head, you should have no problem finding a doctor who knows how to assess the injury risk.
Well, we really appreciate the plug for sportsneuropsychologysociety.com, where you can go and find the sports neuropsychologist.
Exactly.
All right. So in April 2016, what's it in general cost for that system for a high school? Because usually if you mention things with NFL or NHL, you're like, well, that's unrealistic for me. So
we have just about finished the process of migrating the manufacturing of these sensors. into a very high volume, low cost consumer electronics factory run by one of the biggest consumer electronics manufacturers in the world, a factory in Zhuhai, China. I would just spend 2 days there as we'd be in the process of ramping it up, so we can manufacture these things at much higher volume, much lower cost. We can make these things. I mean, we are targeting 22 million youth athletes, youth through high school under the age of 19 today, who play sports that have concussion risk. So everything from football, hockey, soccer, lacrosse, basketball, wrestling, as well as some other fun stuff like BMX cycling, like skiing, aerial skiing in particular, horseback riding. 22 million young athletes who, under the laws now, youth concussion safety laws, have to be monitored, and someone has to act on any suspicion that they took a head impact that can cause injury. Right? So we have the most comprehensive tool to do that. We don't sell anything. We simply license it. We give you everything you need for as many players you need it for. The cost is $150 per player per year, and that gets you the wearable impact sensor, access to the entire cloud data platform, all the data storage, analysis, automatic reporting, the application that runs on your iPhone or your iPad, and the neurocognitive assessment tool that you can use to do baseline testing, as well as post-impact assessment. And it's the only end-to-end solution on the market. There are lots of additional bells and whistles that could be added. We likely will add it in the future, but today it is good enough. And again, has been shown in a number of landmark studies into which we simply provided the equipment. So independent third parties, including some of the best-known concussion researchers here in the country, several of whom are giving talks there, will be tomorrow, have shown that just do that, gather the data, look at the data, look at the very simple messages telling you, and you will greatly enhance the safety of your athletes and soldiers. And we've recently done interesting numbers, review with insurance providers. What does a concussion cost? So if a high school athlete gets a concussion, or run-of-the-mill concussion where it's been identified they should be removed from play, they have to be assessed and then signed off before they return to play, typically generates billings on the order of $15,000 in the system. So at $150 a kid, you can, for that same $15,000, you can put these patches on 100 kids. And we don't reduce the concussion count in a season typically by, one. It's 5, 10, 15. The message there is that these things pay for themselves, and we're beginning to see some very significant interest from insurance providers to say, look, we'll be happy to provide insurance for your high school or club or youth athletic activity, but you're going to have to wear these sensors. In return for that, we're actually going to reduce your premium because we're going to save money and you're going to save heads. So there is a world in which this is very economically attractive, because teams, you'll just get it as part of your insurance package. Not unlike my automotive insurance people have offered to give me a very big reduction in my insurance if I simply take a little motion sensor, very analogous, and stick it in my car to prove that I don't drive faster than 65. I don't continually drop my car into park while I'm moving and jam the trench. I don't hit speed bumps in a manner that cracks my engine block, right? If it works for my driving insurance and my kids' driving insurance, sure as hell is going to work for their heads as well, right?
Works for me. Any more questions?
I think I'm out.
Okay, let's get this out in the air. Jimmy Fallon, all those other late night guys, and let's get the message out there.
Absolutely.
Right. All right, the aspiring Dr. Biesman, the Dr. Ralston, and athletic trainer Jeremy Jackson. We're at the Sports Neuropsychology Society's annual conference, 4th annual conference here in Houston. Using hashtag #TheSNS2016. You can watch the video on YouTube, or you can tweet any of your questions today or tomorrow. And great interview with Dr. Ralston, representing the X2 system and a sponsor for the Sports Neuropsychology Society conference this year. Thanks.
Thank you.
Thank you both very much. Okay, off to the 4 o'clock. Yes. Remind me to show you the
photograph. Oh, yes, yes.
I got hauled up to Washington, D.C. last week to present.
All right, is everybody ready to rumble? All right. So our next event is point counterpoint. Do concussions cause CTE? A debate on the relationship between head trauma and CTE. And our presenters have agreed to an order. So Dr. Cantu will go first, followed by Dr. Barr. And I'll read their bios in just a second. But this is I really feel like this presentation exemplifies what Sports Neuropsychology Society does so well, is that we want to look at the whole picture. We want to look at both sides, if there is a side per se, but we want to look at all the perspectives so that we are very educated and can determine what's the best course for protecting the patients that we work with and dealing with their injuries and getting them back to their activities. So Dr. Cantu will be presenting first, so I will read Dr. Barr's bio first. William Barr, Dr. Barr, is the Director of Neuropsychology and Associate Professor of Neurology and Psychiatry at the NYU School of Medicine. He has over 25 years of experience in clinical practice, training, and research in the field of neuropsychology. Dr. Barr is on the editorial boards of 4 professional journals. He has served on committees and boards for various neuropsychological and psychological organizations, including a term as president of the Society for Clinical Neuropsychology, Division 40, of the American Psychological Association. He has active research programs on cognitive and behavioral aspects of epilepsy, sports concussion, and forensic neuropsychology. Dr. Barr has also served as the neuropsychological consultant to a number of sport teams, including the New York Jets and New York Islanders. He maintains an active forensic practice, including many high-profile criminal cases, in addition to civil cases involving mild traumatic brain injury. Dr. Cantu is a clinical professor in the Department of Neurology and Neurosurgery, Clinical Diagnostics, and Therapeutics Leader, AD and CTE Center at the Boston University School of Medicine, and Medical Director and Director of Clinical Research at the Dr. Robert C. Cantu Concussion Center at Emerson Hospital. He has authored over 400 scientific publications, including 32 books on neurology and sports medicine, in addition to numerous book chapters, peer-reviewed papers, abstracts, and free communications and educational videos. He has served as Associate Editor of Medicine and Science in Sports and Exercise and Sports Science Review, and on the editorial board of the Physician in Sports Medicine, Clinical Journal of Sports Medicine, and Journal of Athletic Training. Dr. Cantu serves as Senior Advisor to the NFL Head, Neck, and Spine Committee and Section Co-Chair of the Mackey White National Football League Players Association TBI Committee. And he is the founder and medical director of the Concussion Legacy Foundation. He also consults with numerous NFL, NHL, and NBA teams. So this is an incredible honor and opportunity for us to have these 2 incredibly accomplished professionals here to talk about the topic of CTE. And just let me tell you briefly about the format that we're going to have this afternoon. Dr. Cantu will present first for 25 minutes, and we are going to keep them to the time. So Dr. Bruce is going to help with timekeeping using my senior psychometrist, official psychometrist stopwatch. And then Dr. Barr will do the counterpoint for 25 minutes. Dr. Cantu will have a 5-minute rebuttal, followed by a 5-minute re-rebuttal by Dr. Barr, and then we will have questions and answers so that you will all have the chance to ask your questions and have the responses from our presenters. So, gentlemen, if you will come up here and join me, we'll get rolling.
Thank you. It's a pleasure to be here, and I hope that we all enjoy this session. It'll be entertaining, I'm sure, and hopefully informative as well. We're going to be presenting essentially our views with regard to the relationship between head trauma and CTE, and since concussion does involve head trauma. It is, and therefore related to the pathogenesis, we believe, of CTE. But you don't have to have a concussion to wind up with CTE if you've had enough subconcussive trauma. Some disclosures. First involved with this subject over 20 years ago when we were editing a book called Boxing in Medicine, and wrote the chronic traumatic injuries with boxing section of that, and in it chronicled the work of Harrison Martland, who put dementia pugilistica on the roadmap in the 1928 JAMA article. He described essentially the clinical symptomatology of it in boxers and the gross anatomy, and correlated the two. More recently, there's been an awful lot of hype about this and a lot of misinformation, some of which I hope we can put a little bit more down to the rational stream of where science is, which is far behind the hype. Part of that hype was a recent movie in which Dr. Malu was on duty when Mike Webster's body came in, and he suspected that maybe Mike had CTE, and he had Dr. Dukowski look at his brain, and sure enough, the neurofibrillary tangles of CTE were seen, and the first case of CTE in an NFL football player was documented and written up shortly thereafter in neurosurgery. This quote from the movie is some of the liberties that the movie takes. The disease was described way back in 1928 by Harrison Martland, and the neuropathology of it was described by Corsalis in 1973, including the neurofibrillary tangles that are so characteristic of the disease. The disease was described in boxers, and the cerebellum was disproportionately involved, and we can get into that if we need to in terms of why we see structural differences between the CTE of boxers and the football players of today, where the cerebellar pathology is not nearly so dramatic, the motor pathology is not nearly so dramatic. The first person to actually call it chronic traumatic encephalopathy was MacDonald Critchley, an English neurologist, in a book euphemizing Clovis Vincent, a French neurosurgeon. CTE was thought about in terms of football players as far back as the 30s. They were described in various newspaper articles as stumblebacks or punch-drunk football stars, and it was thought at that time, stumblebacks, does football make players stupid? So people were thinking about the association of repetitive head trauma in football players and later life issues that were somewhat similar to the CTE that we see today. The team at BU that we originally were involved with involved Chris Nowinski, the former Harvard football player and wrestler, who procured the brains for Dr. Ann McKee down in the bottom left, who is now the neuropathologist who's seen more cases of CTE than anybody in the world and has published more cases than anybody in the world. And then Dr. Bob Stern, who is in charge of the clinical studies, trying through biomarkers in terms of blood, saliva, CSF, as well as imaging studies, to see if we can't be moving along the spectrum of diagnosing CTE in living individuals, something that we can't do today. It's only a post-mortem diagnosis. This was the first article that Dr. McKee published in 2008 in the Journal of Neuropathology. She added a couple of cases of CTE and in addition reviewed the world's literature on published cases of CTE. This article on the bottom is one of her latest publications, which are now in the 40s on the subject of CTE, and she actually now, through NIH funding, has 4 other neuropathologists that work with her, and it's an incredible team effort especially including the young PhDs and the graduate students that are part of that team as well. In this particular article in Brain in 2012, she published the largest series of CTE patients, 68 cases out of 75, and on the right-hand side, you see the grading system that she proposed for grading of CTE, where the first two grades, in grade 1, they're relatively isolated, rare clusters of the hyperphosphorylated tau at depths of sulci around blood vessels. In grade 2, many cases of grade 1 are asymptomatic. In grade 2, the clusters of tau become a bit more numerous, but there has not as yet been involvement of the medial temporal lobe, which is disproportionately involved in grades 3 and grade 4. Virtually everybody in grade 3 and 4 is symptomatic. The triad involving cognitive, behavioral, and mood issues, but not everybody necessarily having all three. I think it's important to understand and repeat that this is a neuropathological diagnosis, so you can argue that Bill and I can have fun today, and it really should be neuropathologists in many ways that are carrying on this discussion. But in February of 2015, neuropathologists from around the world convened in Boston, and this was funded by NIH, and out of it has come the criteria for diagnosing CTE. And the criteria for diagnosing CTE, the pathognomonic lesion that must be there for that diagnosis to be confirmed, is the aggregation in a patchy, irregular distribution of the hyperphosphorylated tau at the depths of sulci around blood vessels. So it is at the depths of the sulci that you see the tau, and it's around blood vessels, and it's a patchy hit and miss accumulation, not a homogeneous diffuse accumulation. There are other tauopathy patterns that go with it. Characteristically, it's in the superficial layers of the cortex, 2 and 3, and not in the deeper layers, 4 and 5. But these are only associated things, and they're supportive of CTE, but in and of themselves are not diagnostic of it. There are other things supportive of CTE, but not diagnostic of it, that deal with structural issues, such as dilation of the third ventricle, fenestration of the cavum, wide cavum septum pellucidum, especially those with fenestrations, atrophy of the mammillary bodies, and or contusions or other signs of previous brain injury. And there are also other proteins that are frequently seen but are not pathognomonic of CTE, TDP43, occurring in the hippocampus and especially the amygdala. And there are also age-related accumulations of tau that can happen that are not diagnostic and not supportive of CTE. And in fact, these are only usually seen at extreme ages. So I think it's important to understand that CTE is not aging. The tau in aging is not perivascular, it's not at sulcal deaths, it's most severe in the entorhinal cortex early on, and in CTE it's only in the later stages that you have involvement of the entorhinal cortex. CTE is not Alzheimer's disease. The distribution of the tau in Alzheimer's disease is not perivascular, it's not at the depths of the sulcus. Alzheimer's disease involves its deposition in layers 5 and 6 of the cortex, not in layers 3 and 4. And in Alzheimer's disease, you have amyloid beta plaques as a very prominent component of the illness, of the disease, with more than In CTE, 50% of cases roughly have absolutely no amyloid beta whatsoever, and those that do, it is not nearly as prominent as it is in Alzheimer's disease. So the pathology of Alzheimer's, the pathology of aging, is not the pathology of CTE. Some of the criticisms that have been weathered by the group at BU is that CTE is seen with other neurodegenerative diseases, and maybe this is obscuring it. Well, it is seen with other neurodegenerative diseases, and all the other neurodegenerative diseases are seen together. Roughly 50% of cases of CTE are not pure CTE, they're CTE plus something else. Alzheimer's, frontotemporal lobe dementia, etc. But they have the unique pathology of CTE and the signature pathology of these other conditions when they are comorbid. There have been criticisms that CTE cannot be diagnosed during life, therefore it is not a distinct degeneration. This is true, that with certainty it only can be diagnosed with neuropathological staining of the brain for the hyperphosphorylated tau, but there are many other neurodegenerative diseases that are in the same situation. So that in and of itself should not raise any concerns about the entity itself. It is true that all cases of CTE have been involving observational science. This isn't something that you can run an experiment of these people, but that's exactly what has been the situation with other neurodegenerative diseases and a number of other diseases in the beginning, whether it be AIDS, Alzheimer's, lung cancer, etc. In fact, there are many, many similarities between the smoking issue and the CTE issue. It is also true that there is not a well-defined clinical phenotype of CTE. We sit with consensus conferences every 2 weeks, twice a month, where we hear 5 or 6 cases, see the imaging that was done, and then we vote whether we believe it's CTE, probable, possible, or not, or one of the other neurologic conditions or neurodegenerative diseases. In virtually all of these situations, we can't be certain whether we're dealing with CTE or not. The reason that the clinical profile of CTE is taking so long to work out is undoubtedly partly related to the fact there's so much overlap with these neurodegenerative diseases. If you're going to have CTE plus Alzheimer's or CTE plus frontotemporal lobe dementia, it's not a great surprise that the clinical profile of symptoms isn't specific. Multiple publications have come out, mostly by Bob and his group, that have hallmarked the triad of CTE involving cognitive, behavioral, and mood issues, the behavioral issues being mostly disinhibition, rage behaviors, explosivity. In the mood area, it's panic attacks, it's depression, anxiety, and in the cognitive area, it's recent memory, but progressive over time to frank dementia. This is a case of a young man that died, and his brain was looked at, and he had CTE in what essentially would be grade 1. He was symptomatic at the time that he died. How could this be from that small amount of tau that was present in his brain? Well, CTE involves much more than just the hyperphosphorylated tau. It involves a breakdown of the blood-brain barrier, it involves neuroinflammation, it involves neuronal loss, not so much in the beginning as later, but it also involves axonal degeneration. It is an axonopathy, and it's thought most probably that the symptomatology of the early stages of CTE are more influenced by the axonopathy than they actually are the tau. And this is his brain that simply shows a small area. How much? Okay. I'm going to try to focus now on the arguments that CTE is related to repetitive head trauma, and repetitive head trauma is therefore associated with basically every case. Obviously, you can't do a prospective study, though you can follow athletes, but athletes have not been longitudinally followed in a prospective way to be able to do it to date. Obviously, that's something that needs to be done. The strongest argument, I believe, is simply the fact that traumatic head injury exposure is a constant in all documented cases of CTE. There also are animal models. Our own Lee Goldstein has a CTE model in which repetitive head injury is producing CTE in animals. At the depths of sulci is where the greatest shear forces occur when the brain is rapidly accelerated, that Jim was showing you in his talk earlier. And it's at the depths of sulci that you find, especially in the perivascular areas, microhemorrhaging occurring. This is exactly the area where the tauopathy of CTE starts, at the depths of sulci around blood vessels. This essentially fits hand in glove with this being a mechanically induced injury that does involve other things, breakdown of the blood-brain barrier, inflammation, exonopathy, so on, and then eventually the deposition of the hyperphosphorylated tau protein. Over the last several years, you're all aware of a number of studies which have shown that you don't have to have recognized concussions to wind up with structural, whether it be DTI, white matter abnormalities, or functional metabolic abnormalities on functional MRI or PET scanning, or even deteriorations in one's cognitive function in people that were only subjected to subconcussive trauma. Subconcussive trauma can lead to microstructure problems even with a concussion not recognized. This is very quickly a little thumbnail sketch of what we've seen in football, and think, what are the statistics? What's the likelihood statistically that the first 5 cases of brains that were looked at of NFL players all wound up with CTE? And in the experience of the brains that have come to Boston University, 90 of 94 NFL players have had CTE, 9 of 11 semi-pro football players, 38 of 47 college players, 6 of 26 high school players, overall incidence 80%. Admittedly, this is not talking about incidence because this is a selected group of people, but statistically, the likelihood of that happening without there being an association is extremely unlikely. CTE has now been pretty much documented, not just by Ann, but by others in rugby players, in soccer players. The group that convened in Boston not only discussed it in military blast victims, discussed it in people that didn't have any athletic exposure, just had repetitive brain injury exposure, such as autistic kids banging their heads, or seizure disorder patients with repetitive head injury with their seizures. And or there was even an individual that was shot out of a cannon. In one of the few cases in women was a battered woman that was assaulted by her husband. Looking at things from a totally different standpoint is this recent article from the Mayo Clinic that looked at their brain bank and went back in and said, all right, we're going to pull out these brains, we're going to look at them again, we're going to use the consensus diagnosis of CTE and see what we find. And what they found is that there were 66, sorry, it keeps moving on me, there were 66 individuals that were athletes that were involved with activities in which they were contact sports, if not collision sports. Most of them football, a few boxing, a few other sports. Of them, 32%, 21 of 45, had CTE. If we look at the control group, which involved 132 males and 68 females, not one control brain had CTE. This brain bank at the Mayo Clinic is a neurodegenerative brain bank, so you might think the incidences of these diseases, meaning CTE, would be higher in this group, and they might be. Right now, there are multiple neuropathologists that are mining brain banks similar to the Framingham Heart Study, where they're not neurodegenerative diseases, and we will, I'm sure, hear in the next year or so what they find. Chronic traumatic encephalopathy, 5 minutes. Chronic traumatic encephalopathy very much exists, but it's under-recognized. The incidence of it is unknown. The exposure levels at both the concussive and subconcussive levels is unknown. We have cases in our Boston experience that had no recognized concussions but had 10,000 plus subconcussive blows over very long careers, especially in football. The associated risk factors are unknown, and the associated protective factors probably are equally unknown at this time. The clinical syndrome is being defined. It has 3 components to it, but not in every case are all 3 components present. The diagnostic pathology has been defined, and I think now we have to relook at literature that really didn't have that pathology looked at in terms of whether those were really cases of CTE or not. Tau pathology is pathognomonic, but there are also other features in terms of it can have amyloid deposition, though not as a prominent issue. TDP-43, blood-brain barrier breakdown, neuroinflammation, axonal degeneration, and neuronal loss. Although further research is needed to identify the critical variables essential to the development of CTE after repetitive traumatic brain injury, including the role of genetics, inflammatory response, age, gender, and substance abuse, the preponderance of evidence supports the conclusion that CTE is directly associated with repetitive brain injury. Conclusion: the disease is associated with traumatic exposure, a constant of all reported cases. The NIH panel that concluded this pathology has only been found in individuals exposed to brain trauma, typically multiple episodes. So in conclusion, this is where the NFL was when Bill and I were standing on the outside making some criticisms. I would appreciate this not be photographed if we could just turn off that streaming for a minute.
Ira Kassan leads a team of NFL doctors who did a study of several hundred active players and reported that the concern over head injuries is overblown.
Is there any evidence, as far as you're concerned, that links multiple head injuries among pro football players with depression? No.
Co-chair of the Mild Traumatic Brain Injury Committee at the time that he gave that interview on public TV, and I think you're all well aware that the Vice President for Health and Safety in the NFL, Jeff Miller, in front of Congress, did acknowledge the link between CTE and brain trauma sustained in the National Football League. So I think we've come a long ways. We have many, many more things to answer. Unfortunately, the hype is still way out of proportion to where the science is, but hopefully we're creeping up. Bill, I look forward.
Oh, there we go.
Sorry about that. Your mere presence fixed it. Okay.
This happens sometimes. Reboot. I had to reboot.
Oh, okay.
Okay.
No worries.
Just rebooting. Wasn't recognized. Yeah.
Changed it.
Hmm?
You haven't changed from what you showed me last night.
From what I showed you last time. I don't know. How many other times do you have to?
So Dr. Barr is actually just rebooting his computer quickly. Should be ready to roll in a second. And when we get to the question and answer section, what we believe we will have available are some index cards. People can write their questions on index cards, and they'll be collected and brought up here, and that'll be the format for our presenters to answer your questions.
So, well, I'm not doing is seeing my, not able to get to my thing. Oh, this is crazy.
I was like, that was a very clever strategy you had. Put a little virus in there.
Hmm?
Thank you.
I have the title slide on, but
Yeah. Do you want want to maybe come up here?
We're good. All right. All right. Thank you, Bob. Thank you all for your patience, and thank you all, organizers, for inviting me here. So this will be the counterpoint. So I have a few disclosures, and Bob referred to this a little bit, that when I started reading up on the sports literature many years ago, over 20 years ago, Bob had written over 80% of what the papers that existed out there, and certainly admire his work over the years. And he and I were, at one point, considered by the NFL to be dissenters together. And at the 2007 meeting, that was the classification we had, and this is recounted in League of Denial. So today we're presenting some dissenting views, but the goal is to do it in a collegial and respectful manner. So I like to start my talks about sports with what is current in the news. And what be more current in the news than the NFL draft? So the questions are from the NFL draft, relevant to today's talk, that so with these young men being drafted into professional football service, do they already have CTE symptoms? Can we assume that? What's the chance that they're going to develop CTE in the next 30 to 40 years? And if so, if these possibilities are high, do we have, as a society, have an obligation to maybe prevent this from happening somehow and banning football? So these are some of the questions that are out there in the media and some of the issues brought up by the existence of CTE. So what I want to do is the goals of this counterpoint are to evaluate the science of CTE, provide a neuro-biopsychosocial perspective, coining a term used by Mike McRae, and he'll share that with you tomorrow. And then also do some conceptualization of some of the media and social effects. Because as psychologists, it's important for us to understand the social phenomena behind CTE and its effects, in addition to the neurobiological phenomena. So Bob did a great job in terms of going over how it all started, in terms of the development of CTE and the number of important studies that came about. And we don't deny that the players are found to have these abnormalities on post-mortem. The question remains, what does it mean? And what are we supposed to do about it? So while I've directly, through my career, experienced these studies coming up and the whole phenomenon of the modern day of CTE developing, I've been aided by a number of useful critical reviews that have been performed by some of our colleagues, particularly Grant Iverson, Chris Randolph, and others. And I will be using many of their arguments in today's presentation. So what I want to start with is that how did we get here in terms of the scientific method, in the sense that how did it become in the media the idea that this is expected? Without, in my mind, the whole thing being totally proven through scientific methods. So I'm a bit of a history buff. And what I want to start with is just an examination of the scientific method and how we go about science. And usually science starts with, there's an observation, hypotheses are made, a number of studies are performed, and then there is some reporting of the results. And in my opinion, what has happened in this, in the case of CTE and the science of it, is that somehow the observations went right to the reporting the results, reporting the results in terms of the media and the media hype, without a lot of the stuff in between happening. And so we want to look at this from a scientific perspective. So how, in a sense, what I want to ask is, how did the alternative hypothesis become the expected hypothesis? So what I wanted to look at is, let's look and see, what is the null hypothesis that is out there? And it took me a while to look through articles trying to find, has anybody stated these hypotheses in such a manner in these studies? Here's one that I found from a study, by just a review provided by Hazrati et al., that the null hypothesis is that aging professional athletes should be as susceptible as the general aging population to a number of neurodegenerative diseases, including Alzheimer's, vascular dementia, Parkinson's, or ALS. And to flip it around, then the alternative hypothesis would be that aging professional athletes exposed to the effects of repetitive brain injury exhibit CTE, which is a condition that is distinct in the combination of its clinical presentation and neuropath characteristics, a tauopathy, from other neurodegenerative diseases. But for some reason, the alternative got flipped. And we're in a position in the science now of proving that this doesn't exist, when the opposite, in my mind, should have happened. So to do this, let's look at the causal mechanisms that have been proposed. And this is a sentence that came from Anne McKee's 2012 paper, where this particular sentence is repeated at least 4 times in the paper. The sentence saying that chronic traumatic encephalopathy is a progressive tauopathy that occurs as a consequence of repetitive mild traumatic brain injury. So teasing it apart, and forming for the base of our analysis, repetitive brain injury leads to tau pathology, which leads to clinical CTE. So let's see, is that causal relationship, is there evidence to support that? And how do we do that? And as Bob said, that we've gone from observations, and observations are very common in way of doing science. So let's look and see in terms of the history, how we do this, and what are the methods that are available to us. For this, I'm going to go to another English scientist, Sir Bradford Hill. I'm not sure if you folks are familiar with him, but he's a very famous British medical statistician who was intimately involved in discovering the link between smoking and lung cancer, and which is not, the irony doesn't go unrecognized when people are talking about the same kind of parallels with the NFL and football. So what Bradford Hill is important in starting the field of modern epidemiology, the lung cancer studies, and a pioneer in the use of randomized clinical trials. Hill's, perhaps his most famous address, was a presidential address in 1965 that is published in the British Society. And it was a response to Ronald Fisher, the Fisher's exact test and randomization and that. And Fisher criticized the methodology used in observational studies, saying that that's not real science, you can't really prove anything from that. So this address that Hill made summarized 9 points that he talked about in terms of establishing a causal relationship through observational studies. And throughout the paper, he eloquently uses examples from smoking studies that were performed and other studies that performed in British workers, establishing links between disease and occupational exposure. So what I wanted to do is go through quickly just some of these points and examine CTE from these points. So let's go with the first one, being strength. So what the idea is that does repetitive brain injury lead to tau pathology to clinical CTE? So in terms of the strength of the observation, how many cases are we actually seeing? Millions of athletes have participated in contact sports over the years, but the total number of documented cases of CTE, the last count that I could find that existed in the literature was Joe Maroon's summary that was performed earlier in the year, which about 153 cases documented. A lot of the cases, it is also noted that have been reported in different papers. There's 43% overlap in a lot of the reported cases. So it seems that there are more than there really are. But the 153 cases, Bob can give me the update on what the lab is showing now.
But the other part is epidemiologic studies haven't been performed, so we really don't know the true incidence of CTE, and the strength of association remains unknown and unquantified. Number two, the consistency. Well, for one thing, there are a number of differences between the modern form of CTE that is described now and the classic form that was described by Martland in the boxers and that. So one might argue, well, maybe it's a different form that is seen in the boxers, and that's important then to know and understand and study. But there's some inconsistencies there. Different neuropath criteria from different labs. Some of the proponents of CTE have had different criteria in their labs in terms of what the gross specimen looks like, and some of the neuropathologic characteristics have differed across labs. And not every lab observes CTE pathology in exposed athletes. There are a number of reports where the incidence or the percentage of cases with CTE in athletic populations has differed, in particular studies coming out of Canada. So looking at the consistency, there's no consistency in the methods and findings as proposed clinical pathologic features across labs and across populations. Specificity. We know that tau is present in normal brains, and high percentages of tau is present in brain banks where the individuals are come to post-mortem and not identified as dementia patients. Tau is observed in a number of neurodegenerative conditions, including Alzheimer's and others, as Bob pointed out, but there is, in fact, overlap between tau pathology. And then, of course, the clinical presentation, the cognitive and behavioral features observed in a number of other are observed in a number of other clinical and neurodegenerative conditions. So, in terms of the proposed pathologic and clinical features, while there's arguments about some of the specific forms of tau deposition in the sulci and around in the perivascular areas, there's a huge overlap between the conditions. Temporal sequence. That it's important to know that what are we talking about when we're talking about repetitive brain injury? That remains that needs to be defined. How do we define a subconcussive blow to the head? And we've had a number of studies using the helmet sensor technology that have led us with some variable results, some successes, still some questions are open. So we still have a lot of questions there. And in terms of the temporal relationship, does a propensity for tau pathology make one more susceptible to the effects of repetitive brain injury? We have to look at the predispositional features. And which comes first then? Does somebody have tau pathology to begin with and then they develop this? Or is it solely from repetitive brain injury? So, and we also know that tau pathology is observed in those not exposed to repetitive brain injury. So the proposed clinical pathologic mechanisms and sequence of CTE still needs to be established. In terms of dose-response relationship, CTE is reported in a range of individuals, including young high school players and older retired athletes. Is there a relationship between football position and years of exposure? There's a variable relationship between the degree of pathology and clinical presentation. This dose-response relationship still needs to be established. In fact, another disclosure, though, I want to note that Bob Stern is conducting a study on this, and I'm involved in the NYU arm of that study in terms of looking at the dose-response relationship, and hopefully we'll get some useful data from that study. In terms of the experimental evidence, no conclusive results from animal models, while some promising stuff, including the new stuff that Bob just showed, very interesting. But we know in general that there's been a lack of an animal model that truly mimics the effects of concussion, sports concussion itself, and of course CTE. In terms of doing other experiments, there's no identified means we've developed yet to prevent CTE in those that are exposed, other than well, we don't even know if you pull somebody from football competition what really happens. And of course, unable to perform true experimentation on human samples in relation to this. So no conclusive evidence from experimental studies. In the interest of time, I'm lumping the last three, but basically the idea is that is there an analogy in other aspects of science? And we do know that there is an association between moderate to severe TBI and dementia. And it's important to see what are the similarities and differences in the more severe, moderate to severe model, and how that relates to what's being reported in TBI. Okay. All right, so in terms of Hill's criteria for causation, there's question marks for a lot of these features. I think many more question marks than we had in the point in 1965 when Hill gave this address regarding the relationship between smoking and lung cancer. So in my mind, it's that we still have it's premature to assume that there's a causal relationship between repetitive brain injury and the underlying pathology. My next step is I want to just talk a little bit about a neuropsychosocial perspective. As a neuropsychologist and speaking to an audience that is predominantly neuropsychologists, I just want to have a few things to say about the presentation, about CTE and suicide, and neuropsych findings in general. So the major question we have to address with our patients and the society in general is who's going to get CTE? So starting with this handsome young lad who played hockey in football in the 1970s, the question I had was, who's going to develop CTE? All right, if you played football and you're in a certain age group, are you going to get it? Do you have it? I know what's going on there. So what I did was an informal analysis, taking information from the National Federation of State High School Associations, looking at football participation in high school football in the United States, taking males aged 45 to 60 years old now, looking back on the years that they played. As you see, over those years, 1970 to 1988, the number yearly participants in high school football ranged around 1 million. What I did then was divide that number by 3 to get a rough estimate, meaning that to look at individual participants who played no longer than 3 years of varsity football. And this, again, is 11-man football. When you look at those statistics, I was amazed at the amount of schools that played 8-man, 10-man, and all these, but this is statistics for 11-man. So we get an estimated total of 6 million individuals that would be in that 45 to 60 age group. So looking at the predicted rates of CTE, while obviously there's no incidence statistics are there, but things have been thrown out, and ranging from 0.22 in the NFL settlement, okay, might be low, to 79% from the Boston Brain Bank, which just a similar quote to what Bob just had. So if we just even look in the middle there, and from some of these other studies, we would be seeing around 1 million men in this age group presenting to our offices for assessment of CTE. They'd have the clinical symptoms of CTE in this age group. And I want to ask you, in each of your offices, do you see a large number of people knocking on the door asking for evaluations of this condition? Are we missing it? What's going on? Or perhaps it's not going as high a rate as presented. As neuropsychologists, we appreciate that the clinical features of different conditions are not specific to CTE. There's a high overlap in the presenting symptoms with depression, dementia, and other conditions. And one of as a clinician, our job is to try to tease this apart. This is what, in my mind, neuropsychologists do best, is take these behaviors and try to figure out what's going on with it. Neurobiological, psychosocial, whatever, what's going on. What we have in the press is a lot of coverage of bad things that NFL players have been doing. And I've heard some say that, well, maybe this is exactly what we're talking about. CTE is expressing itself in these players, and they're doing things, domestic assault, drug use, and other things, and this is all caused by CTE. I think that's a pretty strong argument, but that possibility is out there, and people have presented it that way. I just wanted to include this quote here by Ellen Schwartz, a prominent New York Times reporter, who many fault for covering the CTE story a little too vociferously, but in this particular quote, he said basically, if we are explaining all these behaviors on CTE, then we're doing a disservice to the science itself. That we still got to consider that people can just be jerks or whatever he says in the thing, and not have to explain it neuropathologically. So the other part of that is that one of the features we know when one of the things that's thought to be distinctive about CTE presentation is aggression, and that is that the CTE individuals have more aggressive tendencies than others. In terms of dementia, one of the presenting features that we always tell our patients are that pre-existing traits get exaggerated. So when we're talking about groups of individuals that are recruited for aggression, and then later in their life they exhibit features of aggression when they develop symptoms of dementia, that it doesn't seem as much a causal factor as one might think. All right, the next part is CTE and suicide. This is one area where perhaps the most damaging idea that has gotten into the media is the idea of suicide and CTE, where tau in the brain is believed to have caused the suicide. This is something that Grant Iverson has written on eloquently in several publications, and it's something that definitely warrants our attention. So we know that suicide is very multifactorial, and by stating that suicide is the result of tau pathology is somewhat makes it somewhat simple. That saying that it's all based on this little square here of this complex psychosocial diagram might be a disservice to all. So, but somehow suicide has been hijacked from psychiatry, psychology into neuropathology through this process, and it's disturbing. One of the other things we know about suicide is that it's increasing in the United States, and that there are, in particular with regard to white men in their 40s. So are we to think that this is the same group that played football, the group in their 40s? That's one possibility. But I think we know that there's a lot of social factors that are going on in middle-class America that has been thought to lead to this, and as evident in what has gone on in the Trump campaign, a lot of people that are dissatisfied with the way things are. So the point is that there are social factors that can explain the behavior of this group, as well as biological factors. And one of the things we also know that retired football players, while the rate of suicide and depression is lower in NFL players than the general population, that the NFL players do at a time of retirement have symptoms of depression, can be exacerbated by pain, and also one of the things that we want to think about is, do we, by characterizing their behaviors at this point in their life as due to incurable dementing illness, deprive them of much needed treatment for a very treatable illness like depression? Something to think about. From a neuropsychological standpoint, I know my time's running out, our studies performed by Monroe Cullum, Chris Randolph, and others have not had the same kind of provided the same kind of model. There's been a lot of similarities to depression and MCI when you use neuropsych methods or neuropsych batteries, and it's thought that maybe what the exposure through repetitive brain injury or whatever is doing is lowering the cognitive reserve, and it's a model consistent with what Doug Smith and others have provided, that some of the features that the brain injury might serve is to lower the clinical threshold. So in conclusion, I just want to go with, how does all this happen? How did all these social effects influence the media and that? How did we go from these observations of a few cases to the state we're in now? Well, what we know what we're up against are huge media coverage through television shows, through the movies. What we're in a situation is that those who start to question this model now have a label. They're CTE deniers, okay? How did we get there? And how we got there, I want to share in the last seconds, is through social phenomena, that social psychology phenomena that we can use to understand these things, is that something that's written about called the availability cascade. Basically, you get some observations that are published, the public gets it in their mind that, here's the story. This emotional story becomes the story itself, prompting additional coverage in the media, which in turn produces greater concern and involvement. The cycle is sped along in some cases by what they call availability entrepreneurs, people who want to keep the story going. Then the news coverage becomes more and more sensationalized because they're in competition. Who's going to get the best CTE story now? And then scientists and others who try to stop this phenomena or question it then become the CTE deniers. So there's a real clear social phenomena that seem to occur here. It's occurred a number of times in history, and I believe it's occurring now. So in conclusion, that when I started out in the 1990s, our goal was to try to convince coaches and the public that concussion was a problem. In the 2000s, with media coverage of CTE and other things, the media exposure got to everybody. And now, in the 2010s, our hope that convincing the public at large that concussion is a condition that we can manage safely and effectively and not proven to be harmful to children participating in these sports. So thank you.
All right, and now Dr. Cantu will have 5 minutes for rebuttal.
Thank you. Excellent job, Bill. I can't solve the media issue. I put that slide up twice because I feel the same way Bill does about it. They're selling newspapers, TV, whatever. Just commenting on a couple of things. First, with regard to, do NFL players entering the NFL's draft have CTE? Unquestionably, some of them do. Hopefully it's asymptomatic, and hopefully it won't be progressive. But statistically, if 90 out of 94 symptomatic individuals have CTE in the NFL sample, it's not arguing very favorably for them if they progress to the point of picking up behavioral, cognitive, and mood symptoms. It's very important that that 80% is symptomatic individuals. We've made the point many times, we don't know the incidence of CTE. The fact that the first 5 players had it, 90 out of 94 symptomatic players have it, make the point, if you're symptomatic of it, you probably have it if you have that amount of exposure. But we don't know how many people that go through their lives and don't have any symptoms have CTE pathology in their brains. That's what the brain bank, the volunteering of giving your brain when you die will hopefully, many years after I'm gone, allow people to know just what is the true incidence of it. With regard to the scientific method, we can't do it here. It's head trauma. The closest we can do it is prospective longitudinal studies of individuals that choose to play sports at high risk of head injury, and I believe we're in urgent need of those studies. We heard Jim talk about some of it going on in ice hockey. Obviously, we need it in all the collision sports, and it's not just for 3 or 4 years. It probably should start at age 5 and follow these people into their 20s at a minimum. CTE is not progressive, most likely, in every individual. The thinking has changed a bit because there's been some cases of individuals in their high 70s and early 80s with fairly early stage CTE, stage 2. And if someone's picking up stage 2 in their 80s when they die, more likely than not, that disease got arrested along the line, because probably didn't start and only get to stage 2 in somebody in their 80s. With regard to the modern or so-called CTE that we're seeing today in football players, the great majority of their trauma is to the front of the head. They hit with their heads. Yes, they take rotational accelerations on every one of those hits, but it's not quite the same as a boxer giving you a hook. And yes, they catch hits to the helmet on the side that spin their head violently, but it's not repetitively the same. And the so-called classic CTE of the 20s and 30s, where there was a lot more cerebellar pathology, is exactly what we saw when we looked at some boxers versus football players. The degree of cerebellar pathology was not as high, not nearly as high in the football players. We think that's due to the fact of the different amount of rotational acceleration that they're taking on average. With regard to the suicide issue, I didn't comment on it, and the BU group has never said that CTE causes suicide. It's a multifactorial issue. It's one that desperately needs to be sorted out. We're not going to solve that now. I'm happy that we'll probably have more cases. More questions about that in the next, not cases, questions from the audience about that. And then finally, the overriding factor here for the CTE argument is that it is a neuropathologically diagnosed disease as of today. And going forward, unless it changes, everything will have to be measured against it. And many, many papers that have been written without the pathology, especially pathology of CTE as it's recognized by the NIH, what it has to have, are not going to really stand the test of being necessarily being CTE issues. The increased incidence that we've seen in the Mayo Clinic series, there's no question that there's a heightened incidence of it in the National Football League. From the statistics that we have, even though we can't say precisely what it is, we have seen a dose effect similar to smoking. Individuals with a longer exposure to repetitive head injury have a greater chance for a more advanced level of CTE than someone who has a lesser exposure. It's also true that as you age, you have a greater chance to have a higher degree of CTE graded pathology. Thank you.
Thanks, Bob. Well, I don't have a huge amount in the SIR rebuttal or whatever formal rebuttal it is, but I mean the question about the NFL draftees. If they indeed have, some of them have CTE, I'd be shocked that are we saying that their behavior is different than other athletes? Would the NFL be able to use that information to negate their contracts or something? I don't know, but I find that shocking. But really, it comes down to what is the relationship between neuropathology and behavior? What makes a diagnosis? Okay, we know there are cases of individuals who come to brain banks that have Alzheimer's pathology, but they showed no signs of Alzheimer's disease in their lifetime. Did those people have Alzheimer's disease? I don't know. People who die of whatever for various causes and are found to have abnormal hearts, whatever. Did they have heart pathology? I guess one might say. But what does it mean in terms of the behavior? What's the relationship between the phenotypic behavior and the pathology? That's the key question. So if we're talking about a neuropathologic diagnosis here, does it fully have full meaning if that we know that there are individuals who will have features of the condition and not have the pathology? Those exist, clearly. Are there, and every possibility does exist that there are individuals who have the pathology and show no behavior. So it really comes down to an argument about behavior. What is disease? What is behavior? But then, taking what we have in terms of the neuropathologic diagnosis and making assumptions about behavior and social policy, that's where I'm getting a little uncomfortable. Thank you.
Hello? Okay.
All right, karaoke time.
All right, thank you all for your questions, and I want to thank both presenters for excellent presentations. So give me a second to look at a couple questions. Okay, let me ask this first question for both of you. While the current science of CTE is not where we would like it to be, are you suggesting that there are no long-term effects of repetitive TBI? And if not, why should we care if people get concussions or MTBI, and why should we keep them from participating in sports until no longer symptomatic?
I guess that starts with me, huh? I'm going to go back to the argument that, of course, hitting your head repeatedly is not good for you. All right. And so there are clearly effects of hitting your head, and we need to understand this and make some develop studies to examine this in a systematic manner, that's about all I have to say.
Well, I would agree with Bill completely, and I would add that hitting your head repetitively at a very early age may carry some greater risk than later. The issue with regard to the NFL players, I was basing on the fact that if we've seen the disease in people that have only played in high school, and we've seen the disease in people that only played in college, it's unquestionably some of these people have entered into the NFL with disease. Were they symptomatic at the time they got into the NFL? Well, maybe. There have been some that tragically died at very early ages in their mid-20s in their NFL careers due to crazy behaviors like jumping off the back of trucks and other things that had CTE, and there's others that have committed suicide at relatively early ages, not just the advanced individuals that had CTE. So I don't have any doubt that if you were to look into the brains of every individual that is currently in the draft, that the possibility is there that CTE is existent in at least some of them.
Thank you. Okay, a recent study found perivascular tau in individuals with temporal lobe epilepsy and no trauma history. So how can you say perivascular tau is pathognomonic for CTE?
Well, let me take that one, because that particular study was done at Cleveland Clinic in part, and they actually took tissue from Ann McKee's lab that they asked, and then did this assessment. And it isn't me. I'm not the neuropathologist. I have not been the one to be funded by NIH to come up with a consensus guidelines for what is the diagnosis of CTE. But the consensus that the tau that was present in that report in 2015 was not consistent with the pathognomonic features of tau that the consensus guidelines had. And I don't want to tell you Ann's words when she actually read that paper and realized they used her materials and then did this work without her having a chance to peek at it and at least consult them.
Well, I don't know the backstory. I've had the opportunity to study epilepsy and understand epilepsy, and I want to look at that paper as an avenue to further research. It shows again that there's a lot of overlap between, well, maybe not exactly or whatever, but there's overlap, and there are things to think about with seizures that with repeated seizures, there are things like effects on blood-brain barrier and other possibilities that I think we should try to look and see some of these similar features between epilepsy and the proposed model for CTE, and come to a larger understanding of the phenomenon.
Biologically, why would repetitive mild TBIs lead to CTE but not a single severe TBI?
Well, there are a couple of cases in the world's literature, two that I can think of, and I don't think there's more, where CTE has been found with only a single very severe TBI. The problem with each of those two cases is that there's not a good history of whether that person really did have any other head injuries over their lifetime. So it's really, you know, the words in the paper are, didn't play contact sports, so not exposed that way, but don't know about other possibilities for repetitive head injuries, as we all, more or less, most of us at least, do pick up some repetitive head injuries. We don't believe that it is the single insult, but we also don't have it worked out. The path of inflammation, microglia that may be reparative early on, and then it's like a wildfire that's out of control. They start being phagocytic. The tau protein is in neurotubules, as you all know, normally. It's only when it becomes hyperphosphorylated that it takes on this toxic component that is injurious to neurons, into axons both, and most of the neuropathologists believe can spread on a prion-like effect once it's kind of gotten out of control and becomes this progressive stage that seems to be the more common phenomenon, but certainly is not, I don't think, in every case the phenomenon. Certainly wasn't in that 82-year-old.
Well, I'm not a neuropathologist either, but I do know that the mechanisms that are thought to occur following moderate to severe traumatic brain injuries involve more amyloid deposition and later on more Alzheimer's looking dementias. So people who've talked about the role of brain trauma in dementia, of which there is a higher rate and a higher chance after a brain trauma, or more severe, it's more of the Alzheimer's type of brain trauma.
If I could just follow up, because it was a point I didn't make during the rebuttal. When we talk about the incidence of something that we would expect when we're talking about CTE, most people don't get autopsied at death. And those that do, until very recently, unless there was a reason to use hyperphosphorylated immune studies for tau, they didn't get those kind of studies done. So until very, very recently, even if you were autopsied, you wouldn't know whether somebody had tau or not. And we don't really know the incidence of ex-NFL players that have died, whether they really had CTE or not, unless their brains were studied in an appropriate way. And that's only something that very recently has been available.
And adding to that, even now, the NFL players who die with quiet lives and not bringing attention and not being heavy coverage from the press are not getting autopsied, and certainly not getting autopsied in Boston. So we do need to know what the other NFL players look like, and over and above the 153 that have been studied.
And we're actually running a little over, and I appreciate everyone's attention. I can tell this is a very interesting topic for everyone. So we have one last question. What role might opioid use play in CTE? Opiate abusers have tauopathy and dementia in animal and human studies.
This is something I failed to mention in my presentation, but there are findings from Scotland showing that there's tau pathology in opiate users. We do know that opiate use and drug use in NFL players is very high. Retired players report about 50% report that they actively used opiate medications during the course of their careers. This just brings up one of the other things. There are competing hypotheses that we need to explore. Opiate use is one of them. I believe that other forms of painkillers like NSAIDs need to be explored too. There's some evidence that NSAID use can be related to development of dementia pathology. So all these other possibilities, and then there's just illicit drug use effects that need to be considered, and steroids. So on that list, I think opiate is at the top because there is existing evidence, but I think we need to investigate other evidence too.
I would agree with Bill that we need to investigate it. I think the important thing to understand is that there are cases of CTE, many, that did not have opioid use, and so it wasn't there like head trauma was there for every single case. But as I indicated, there have to be synergistic factors. There have to be things that are making it more likely for somebody to wind up with CTE with the same amount of brain trauma as somebody else who doesn't have it. And those factors probably are not just limited to genetic issues. Very likely they are limited to substances and or nutritional issues and or other environmental issues. They've just not been identified today, but I would agree completely that they need to be studied.
And on that note that they agreed, let's... Whoops. Thank you.
Hello. Okay, just a quick announcement. Reminder, neuropsychologists seeking CE credits, please turn in your slips as you exit. You will need them again tomorrow. Turn them in. And when you're leaving